Welcome to this course, Blazor Deep Dive, Beginner to Advanced in .NET 10.
In this course, we're going to build a few projects while we dive deep into the world of Blazor. The main project that we're building is a server management project, where we are managing servers in different cities. And we are able to search servers by using the search bar, and we are able to turn on, turn off the servers, and edit the servers as well. We are also able to delete the server. As you can see, we also cover authentication and authorization, some of the user management. Another project that we're building is this to-do list. So you can manage to-do list by using Blazor, and you can mark them as completed. Finally, with Blazor WebAssembly, we're building the server management again, but this time it's a simple CRUD operations with add server from the add server screen, added server from the added server screen, and delete server.
Now let's take a look at the curriculum. In the first section, we're going to talk about what is Blazor, the different choices of interactivities, and basic Blazor project structure. And in the second section, we're going to dive deep into Blazor static server-side rendering, which is the base of everything else. We're going to talk about basic stuff like Razor syntax, basic components concepts, component parameters, form submissions and validations, so on and so forth. In each section, we have more advanced lessons like this one. And in the next section, we are adding interactivities based on the static server-side rendering. We will start with what is interactivity, and we're going to talk about things like interactive locations, event handlings, update state variables, data bindings, and interactive edit form. And we also have advanced topics in this section. In the next one, we're going to work on a course project based on what we have learned, so you have more time to practice. Now the next one is about rootable components. Blazor is component-based application framework. Therefore, thinking in components and being able to work with components is very important in Blazor. And in this section, it's all about components, how to extract different components from existing page component, event callbacks, how to reference a child component, so on and so forth. And then again, we have more advanced topics near the end. We're going to continue with our course project with componentizing everything. Now, we have more advanced topics, lifecycle events in Blazor. It is essential for working well with Blazor. Therefore, this section is very important. And the next one is routing and navigation deep dive. So we have more advanced topics about rootable components. State management is also another advanced topic. It is something that you also need to understand when you really work on real-world projects. After that, we're going to talk about WebAssembly. Most concepts that we have learned in interactive server-side rendering also work with WebAssembly in interactive rendering. So in this section, we're going to talk about the different parts in WebAssembly comparing with server interactivity. So next two sections is all about data access. The first one is about accessing data in server-side rendering through NET Framework Core. And after that, we're going to talk about accessing data in Blazor WebAssembly, where we're going to creating simple Firebase API, and then we're going to consume the API within WebAssembly. After that, we're going to this important section. It's about securing our application based on ASP.NET Core identity. And last but not least, we're talking about pre-rendering in Blazor, which is a topic that we have to understand. As you can see, this course is a deep dive into the world of Blazor, where you will learn to harness the power of both server-side rendering and WebAssembly rendering to create dynamic user experiences. I really hope to see you in the course.
In this video, let's talk about what is Blazor. In one sentence, Blazor is a component-based single-page application framework that achieves interactivity with C#. So you can see that there are two parts in this sentence. The first part is that Blazor is a component-based single-page application framework. And the second part is that it achieves interactivity with C#. So let's talk about the first part, which is the component-based single-page application framework. And that is different from the traditional web application frameworks. For example, under the Microsoft ASP.NET Core paradigm, we have MVC or Razor pages. A traditional web application framework works like this. You have a user who uses a browser to access the web application. The user sends requests through the browser to the web server at the backend. So this is a request. The web server is responsible to route the request to its corresponding page. And then the HTML that is defined in the page will come back to the browser and will be rendered inside the browser. And if the user sends a different request through the browser to the web server, then the web server is again going to route that to a page. That could be a different page, it could be the same page. Let's say this time the second request comes and it is requesting information from the second page. Then the web server will route the request to the second page, and then the HTML defined in the second page will come back through the web server as a part of HTTP response and come back to the browser, and then eventually the user sees the HTML for the second page. So as you can see that this type of framework is based on pages. Each request target a corresponding page. Well, that is different from component-based single-page application framework. In the component-based single application framework, of course, we're going to have a user, we're going to have a browser, and of course, the user is going to send requests to the web server as well. So those are not different at all. However, the web server is going to route the request to one page and only one page. And so this is, you can call it the root page, or more properly, it's called the root component. Because it's component-based application framework, everything is component. But you can still call this root component a page if it's easier for you to understand. So all of the requests, no matter how many requests the user sends, it will always go to one single page. And then the Blazor framework is going to look for different components. And what it's going to do is going to find a component and place that component inside this root page component. For example, this first request comes, it knows that it needs the component 1, then it's going to place this component 1 inside the root component. And then maybe the next request comes, it needs component number 2, then this time it's going to replace component 1 with component 2. From the outside, the user sees the same as a traditional web application framework. Right? It just changes page by page. But at the backend over here, you can see that this is no longer page-based application framework anymore. This is component-based application framework. And on top of that, each one of these components may consist one or more child component. So for example, this component may have 2 columns, and each column is implemented by using a component. And furthermore, this left component may have its own child components. So therefore, we have a component tree, and there could be as many levels as necessary. When you start working with Blazor, if you had experience with traditional web application frameworks, you will immediately see the differences between traditional web application frameworks where you are working on different pages. Here in Blazor, you are working on different components, and you will be thinking in components instead of pages. Okay, so that's the first part of the statement. In the next video, we are going to talk about achieving interactivity with C#, which makes Blazor completely different from other single-page application frameworks like Angular, React, Vue.js, because those single-page application frameworks uses JavaScript to achieve interactivity, whereas in Blazor, we're using C#, but we're going to talk more about it in the next video. In this video, you just need to remember that Blazor is a component-based single-page application framework where you are going to think in components instead of in pages. All right, that's everything I want to talk about in this video. I will see you in the next one. In the previous video, we talked about the first part of the statement, which is Blazor is a component-based single-page application framework. In this video, we are going to talk about the second part, which is it achieves interactivity with C#. So then what is interactivity? Let's take an example. If we have a page, and on this page, we have a list like this. Now, we want to allow users to search lists based on a filter and only produce the list that matches the filter. For that, we may have a search bar like this. So you're going to input something here, and then you click on this button, and you expect this list to change. In a traditional web application framework or in modern single-page application framework like Angular, React, Vue.js, you have to implement this with JavaScript. So we click on this button, you code some JavaScript. You use JavaScript to call the backend data. Once you retrieve the data, then you will render this list with JavaScript again. So that's how you do it in other single-page application framework. Whereas in Blazor, we are going to use C#. So therefore, you can see that we're going to use C# on the front end as well as on the back end. So that's one of the best parts of using Blazor. You no longer have to rely on JavaScript, although in some cases you still need JavaScript, but not as much as before. You're going to find yourself use C# in more than 90% or maybe 95% of the cases. In terms of interactivity, Blazor implements interactivity with different options. And the first option is, ironically, no interactivity. So Blazor provides you a way to implement your application without any interactivity if your application does not actually require interactivity like this. That's actually the base of all of the other interactivities. In the next video, we're going to talk about the project structure, and you're going to see exactly what I mean here. So this is the base, and this is also called static SSR, which stands for static server-side rendering. In most of the cases, you're going to start your application with static server-side rendering, which means there's no interactivity. And this is very similar to the traditional application right here. And only when you need interactivity, for example, in this case, you would need interactivity. At that moment, you will add interactivity on top of your static SSR. And when you need to add interactivity to it, there are two different ways to do this. The first one is called server interactivity. It is also called interactive server-side rendering, which is the opposite of static server-side rendering. And the second one is called WebAssembly interactivity. It's also called interactive WebAssembly. Let's borrow the diagram here, and I'm going to start with static SSR, which is the same as traditional web application, where the user interacts with the browser, sends a request to the web application, and our Blazor web applications is going to render HTML back to the browser as HTTP response. Right, so this is Blazor's static server-side rendering, and if we find that we actually need interactivity in our components, maybe a different page component, then we have a choice to use server interactivity or WebAssembly interactivity, as I mentioned before. When we use server-side interactivity,
and when a user tries to load a page, the first request is the same as static SSR, which means it's the same as traditional publication. So the browser sends a request to the server, and then the HTML and all of the static assets, including JavaScript, will come back to the browser. So that's only the first request. One of the important static assets is a piece of JavaScript downloaded to the browser, which is responsible to establish a SignalR channel, which is a WebSocket channel. And it is through the SignalR channel the interactivity is achieved.
I'm using this silver bar to represent the channel that is established between the browser and the server, which is a peer-to-peer communication, and that connection needs to be sustained in order for the communication to be working. And in order to help the browser to be able to talk to the backend applications through this WebSocket channel, right, this JavaScript file is not created by our developer, it's created by Microsoft. So we have this JavaScript file to help us to communicate with the backend server. Whenever the user does something, enter something in an input box or click on a checkbox or click on a button, that event will be handled by this JavaScript and send that request to the backend server. and the request is processed by the backend server, and it's going to see the original HTML and the future HTML. It's going to compare them and only send the diff, right, the difference between those two back to the browser. And then the JavaScript file here is going to be responsible to render that difference inside the browser. That way, Blazor is only re-render the page partially. It's not re-render the whole page. And that is different from a traditional web application where the whole page is refreshed every single time, right? So that's how server interactivity is achieved. And now let's talk about WebAssembly interactivity.
Again, WebAssembly interactivity is based on static server-side rendering, which is no interactivity.
Now, the components that require WebAssembly interactivity will be packaged together with .NET Runtime and all of the dependency it allows and a WebAssembly file. Right? They will be packaged together and sent over to the browser. Because all of the modern browsers support executing WebAssembly. And actually, executing WebAssembly is even faster than executing JavaScript because it's near native speed. So therefore, when we have even the .NET Runtime downloaded to the browser, your C# code will run within the browser, supported by .NET Runtime within WebAssembly. Right? That's the default scenario. There's another scenario where your component that needs to support WebAssembly interactivity will be compiled into WebAssembly, and then it will be downloaded to the browser as WebAssembly, right? So there's no .NET Runtime needs to be packaged anymore. Anyway, whether you use the first approach or the second approach, some kind of files will be downloaded from the server to the browser and eventually executed inside the browser as WebAssembly. And therefore, you can see that we can use C# inside the browser through WebAssembly. And actually, there is a fourth scenario where you can mix and match between the server interactivity and WebAssembly interactivity, even on the same page. Right? When you look at the one screen on the browser, even on that, you can have one component that uses server interactivity, the other component uses WebAssembly interactivity. Right? Throughout this course, we're going to talk a lot about server interactivity because it's just very easy to teach. And most of the concepts will apply to WebAssembly as well. So later in this course, you will see sections about WebAssembly and what is the difference between server interactivity and WebAssembly interactivity. And you have chances to practice using WebAssembly interactivity as well. But for this video, you just need to remember that
static server-side rendering is the base of everything. So you usually start a project with static SSR.
And then when interactivity is required, you have a choice to add either the server interactivity or the WebAssembly interactivity, or you can add them both and use them together. And throughout the course, you will learn how to do that. So this is everything I want to cover in this video. If you have any questions, please let me know. If not, I will see you in the next one.
Let's start creating our Blazor project with static server-side rendering
so that you can start understanding the project structure
of static SSR,
which is the base of all of the other type of Blazor project. Okay, let's go to Visual Studio here. So let's go to File and go to Create a New Project. And here, what we're going to search for is Blazor Web App. Let's click on Next, and then you choose a location, provide a solution name. Here, I'm going to call it Blazor Deep Dive. And this project is a server management project. So we're going to create a server management application for teaching purpose.
Now click on the Next button, and we come to this slightly complicated screen. Of course, we're going to select the latest version. In this case, it's .NET 10 preview. And then for the authentication type, we're going to keep it as none because later we're going to talk about authentication and authorization. And for this HTTPS, we're using HTTPS to make the application secure. And then now it comes to this interesting part, interactive render mode. So if we open it up, you can see we have none, server, WebAssembly, and auto. And the server is the interactive server render mode, which is the server interactivity that we talked about. And the WebAssembly is the interactive WebAssembly render mode, which is the WebAssembly interactivity that we talked about. And of course, the auto is the combination between both server and WebAssembly interactivity. When you create your project, I suggest you to start with none almost all the time, because some of your pages, and it's very possible that most of your pages are static pages, it doesn't make too much sense to select the ones with interactivity for those pages. And then whenever you come to a page where you need interactivity, then you can add interactivity later. And we're going to go through that throughout this course. Since we are at the very beginning, we're going to select none to kick off this project. And we're going to include the sample pages. And by the way, when you select none here, you are basically using static server-side rendering. And let's scroll down to see what else we need to change. I think we're all good, and just click on the create button now.
Let's close this and focus on the right-hand side here in the Solution Explorer here.
And let's go to program.cs file. A program.cs file is a basic C# file. So if you have learned C# before, I trust you have learned, because that's one of the prerequisites of taking this course. So you must have already seen a program.cs file. The file runs line by line. And what's special about this program.cs file is that there is a app.run method runs at the last. And this actually runs in a loop. And when it runs in a loop, it listens to the incoming HTTP request. When an HTTP request comes into the application, it's going to pick up by the application, and then it's going to go through all of these lines, right, that is after line 8. It's going to go through this. And each one of them performs its own functionality and take care of different things. But when it comes to the last line here, map Blazor component, it's going to map the HTTP request to a particular component. So if we look at our diagram over here, for traditional web application, we have this function here that takes care of the HTTP request and then generate the HTTP request. But because Blazor is a single page application framework that is based on components, therefore we're no longer just map a request to a function, whereas we're mapping a request to a component over here. Although that when I talk about the Blazor static server-side rendering, I was using a function here, but at that time I said this is like a function, but it's not entirely the same. And we're going to talk about that later. For now, as long as you can see that this function or method actually maps the HTTP request to the app component, which is basically the root component. And where's the root component? It's under the components folder, and you can see it is right here, app.razor. So we call this as a razor component, and this is at the app.razor is actually a special component. It's called the root component, R-O-O-T, root. So the root component takes care of all of the incoming HTTP requests. And if you look at the body element here, we have a router component right here. So when this app component is being executed, this router component will be executed too. And this router component is responsible to map the incoming HTTP request to a component, which is most likely a component that you write as a developer. So it's going to map it to that component, to your component according to that URL. And when that happens, let's go inside the router component. You can see that here's the name of router here. So when the incoming request comes into the router component, once the router component finds your custom component, it's going to then apply the main layout to your custom components. And so far we have some sample pages. So for example, we have a home page, which is very simple HTML, right? But it doesn't have the HTML tag. It doesn't have any layout information. So let's suppose that the incoming URL is /, which corresponds to the root path. So what happens is that the map_razor component method is going to map it to the app component. And then the router component will map the URL to the home component because it corresponds to the location. And then the router component tries to apply the main layout. So where's the main layout? We go to the layout folder. We have a main layout.razor. And over here, we can see that we have all of the layout related to HTML tags. And then we have a body placeholder. So your component, in this case, is the home component. So this HTML is going to replace the add body placeholder. And then you will have a more complete HTML. And this more complete HTML is then going to replace the router component here. And then finally, you have a complete HTML that has a head element, a body element. So now you can see the entire project structure, right? So the program.cs file is the first file that is going to be hit by the HTTP request. And the second one is the app component. And after that is the router component. And after that, the main layout is applied. So program.cs is the first one. App.razor is the second one. The router component is the third one. And the main layout is the fourth one. After the main layout is applied, we have a complete HTML that is ready to be rendered back. So that corresponds to this. So you can see that even with static server-side rendering, we're no longer using just one function that takes care of the entire request. We're using a nested component, and that nested components generate the final HTML, return that as part of the HTTP response back to the browser. Now let's run the application and I'll show you what I mean here.
The application is running. And first of all, let me show you that in addition to this browser that is launched, I have a console application that is launched as well. When I hover over here, you can see that this actually points to my solution, debug folder, and you can see that it says server management.exe. So this is actually a console application, and it tells you that it's listening to localhost at 7152 port number, or it's listening to this at a different port number. And then it tells you where the root path is. So this is the root path. This shows you that this is actually working as a console application, and this console application is listening to two different ports. Right, when the request comes in,
the program.cs right here is going to pick up the request and process the request with different middlewares here one by one.
Okay, let's come back and focus on the application itself. What you actually seeing mostly is the main layout. Okay, so let's take a look at the main layout again. So main layout.razor, and then it has a sidebar. You can see sidebar here on the left, and then the main area on the right. Pay attention to this body here. I'm going to come back over here. So this is the sidebar on the left, and then this is the main area here. So what is being displayed here is the home component. When I click on the weather link here, and as you can see that the left hand side didn't change, right? Because it comes from the main layout, only this part changed. That means the whole sequence that I mentioned is working, right? So because it goes to this URL, then this program.cs map that request to the root component. The root component then uses the roots, which is the router component, to find the corresponding component. And where is that corresponding component? That is under the pages folder here. So that's the weather component. And then the router component here is going to apply the main layout to the weather component, which means all of the HTML inside the weather.razor, right, inside this weather component, will replace this body placeholder, and then this final HTML
will replace this router component here. If I press on F12 and open up the developer tool here, you can see that we have this script. This is blazor.web.js. We have this hash over here, and we're going to talk about this later. But this script corresponds to, if we go to app.razor, it corresponds to the script. So blazor.web.js. And because we have this assets, that's why we added that hash. And we're going to talk about this later. But right now you can see the location of the script is right here, just above the body clothing tag. And if we look at right here, we have this body clothing tag and we have the script. So this comes from the root component, right? The app component. And then we go all the way up. We see this div that is just below the body's open tag. And we go over here. So what is just below the body's open tag? It is this router component. And but where do we see that div? Right? That div is actually from the main layout. Because if we go to the router component, you can see it references this main layout as we talk about. And if we go to the main layout over here, and you can see it starts with div, right? Div class is page. And after that, we see the sidebar. And we go over here, we open up this div. Well, before we open up this div, you can see div class equals page. So this is the same thing, the same element that is in the main layout. And if we open it up, we can see the next element is the div for the sidebar. And you can see it, we have it exactly like this. We have talked about this main layout replaces the router component inside the app.razor. So I'm showing you that it works exactly like that. And then if we look inside the main layout here, and we open up the main element and then the articles element. So you can see this is the weather, right? So this is the weather component that replaced the body placeholder. So we go back to our main layout over here. You can see that under the article element, we have the body placeholder. And in this particular case, because we are looking at the weather component, so the weather component is right here. So the HTML inside this weather component actually replaces this body placeholder. And then the entire main layout HTML replaces the router component tag over here, right? So that's the sequence. Now, if we pay attention to everything that is under the article element right here, but at the same time, if we press on this home button, so notice, pay attention to what's going to change over here. I'm going to press on the home button right now. Now you see that under the article element, everything's changed. It's just replaced by these two very simple lines. That's because we're looking at the home component, right? This home page component shows hello world and welcome to your new app. So this replaced whatever we had before, which is the content from the weather component. Why is that? That's because everything that we're seeing here under this div is from the main layout. But whatever that is within the article element is the body placeholder. But because we're switching to different page component, this body placeholder is being replaced by the HTML of the corresponding page component. And that means whatever that we talked about earlier in this video actually works in a real application.
In this video, we have gone through this whole process of rendering this basic application. We have seen how the request is handled through different levels of components. And through this example, I hope you can see this project structure of Blazor very clearly. So this project structure is the project structure for Blazor static server-side rendering. It is exactly the same if you want to add server-side interactivity. But when you want to add WebAssembly interactivity to your application, there is going to be another additional project added, but how this part works stays the same. So that's why I say that Blazor's static server-side rendering is the base of everything else. Okay, That's everything I want to cover in this video. If you have any questions, please let me know. If not, I will see you in the next one. In this video, let's talk about the types of components. By now, you know that Blazor is a component-based application framework. Therefore, component is everything. And there are two types of component. The first type is called the rootable component. Sometimes it's also called the page component because the rootable component acts like a page. And of course, the second type is non-rootable components, which is also sometimes called reusable component. Let's borrow this diagram that we used previously. So we have a user send a request through the browser to the web server. The web server is then using the MapRaiser component middleware to map that request to the root component. Then the root component uses the router component to locate the actual custom component to be placed inside the root component. Depending on which component the user requires, it then places that component inside the root component. So all of these components that I specify here, component 1, component 2, or component 3, they are rootable components because the router component is able to locate them by using the URL. And then on this picture, what are non-rootable components? They are here. So non-rootable components can be used inside each one of these rootable components, or can be even used inside other non-rootable components. So these are the two types of component. Now let's jump into Visual Studio and start creating these components so that we can actually understand them better. I'm in Visual Studio now, and now let's create a rootable component. So we need a rootable component to act like a page for us to manage our servers, because like I mentioned before, this application is a server management application. So we're going to create a page component. And whether it's a rootable component or not rootable component, they're all Razor components. So technically they're called Razor component, as I mentioned before. So I select Razor component in Visual Studio. And because it's a rootable component, it acts like a page. I don't want to have this component as a suffix. I just want to remove it, and then I'm going to give it a name. I'm going to call it servers, because this page is going to show us all of the servers for us to manage. So we're going to click on add, and then this servers.razor component is created. Now, what makes a component a rootable component? The single most important thing is the page directive at the top. So as you can see, all of these components are actually under the pages folder, which means they're all rootable component. And if you click on home, for example, it has a page directive right here. Go to weather, it has the page directive right here. So for us, we are going to add the page directive as well. And this page directive is the single most important thing that marks this component as a rootable component. And inside the double quotes, we're going to say slash and then followed by the relative path. So for us, I'm going to say servers is the relative path. Let's run the application. All right, our application is running. There are no links over here to link to our servers page. But what we can do is we can manually type in the URL. So we'll follow the relative path. I'm going to say slash servers. Hit enter, and we can see servers, which is the title. That's the only thing on this page so far. That means we're able to navigate to this servers rootable component.
Again, what happens here is that when the user requires the slash servers page to be displayed, the HTTP request will be handled by this middleware. And when it comes to this middleware here, it's going to map the request to our root component, which is right here. And then the router component is going to look at the URL in the HTTP request and map that to our page component over here because we have a matching URL. And after that, it's going to take this HTML and apply the main layout, which replaces the body placeholder. And then all of this will replace the router element right here. And the final HTML, which is the entire HTML right here, is going to then be displayed in the browser.
So this is the rootable component. So you only need to remember one thing for rootable component, that what makes a component a rootable component is the add page directive. Now let's create a non-rootable component or reusable component. And for that, I'm going to actually create a folder. I'm going to call it controls. I like to call reusable component or non-rootable component controls, which corresponds to pages because there are controls in pages. Right? You can just call it components if you like, or anything you like. Okay, so under this controls folder, I'm going to add another Razor component here. And this time, I want to keep this suffix here, and I'm going to call this server component. Click on add. This time, I don't need to add the add page component because we are not going to actually navigate to the server component. The server component does not act like a page. It acts like a partial view. So I'm going to delete this, and I'm going to just use a paragraph element here. And I'm going to say server is online, something like that. And let's just close it. Now, since we created the server component, we can actually use the component inside another component. So where do we want to use it? Of course, we want to use it inside the server's component. So let's add a line break here, maybe another line break here, and then we can directly use the server component as a HTML element, right? So we can have a less than sign here, and then I'm going to say server component, and then use a greater than sign. And this references to our server component. As you can see that it includes all of the namespace. And there are two ways to get rid of this. So the first way is just to delete it and then use a using directive right inside this server's rootable component. So just do it right here. And now you can see the red squiggly line is gone. Right? We can do it this way, but I prefer the second way, which is place this using statement inside the imports component here. So we have this imports component, which is the global place or the central place where we can place our namespace. If I place this namespace inside the imports.razor component, that means all of the other components can reference the classes or the components under this namespace, right? Because I'm going to have many controls, so that's why I prefer to place this namespace inside the imports.razor component so that in the future when I create other components, I don't have to reference this namespace every single time, right? So let's just keep it centralized. Let me close this and come back to this. So I have one server component. I can actually render as many server components as I want. So let's say I'm going to have 2. And then let me go over here and restart the application. Now you can see that I have this server's rootable components, and inside it, I placed 2 non-rootable components. So in this video, you have learned how to create a rootable component. It's also called a page component, and the most important part is to use the add page directive to specify a relative path. And then you also learned to create a non-rootable component, which is also called reusable component. And then we are actually reusing the server component twice inside the server's component. That's everything I want to cover in this video. If you have any questions, please let me know. If not, I will see you in the next one. In this video, let's talk about Razor syntax, specifically implicit Razor expression. We have mentioned that Blazor achieves interactivity with C#. So interactivity is something at the front end. How do we write C# and then reflect that in our web page or components? That's when we need to use Razor syntax. So let's jump into Visual Studio and see what I mean by using Razor syntax to reflect C# variables inside web pages. So let's take a look at our server component that we created in one of the previous videos. So let's go in here, and as you can see, we only hard-coded server is online. So we cannot always hard-code something because obviously our application framework should allow us to work with dynamic stuff, right, which is variables. So let's say we declare a variable and we're going to say status. Let's initialize it with server is offline just to make a difference. And how do we display this C# variable value inside HTML? That's when we need to use razor syntax. One of the simplest one to use is the implicit razor expression, which means that you start with the @ followed by a variable or a statement. For example, we can say status, and then when the application runs, it's going to actually take the value from the variable and then replace this razor expression. So you're going to see server is offline. Let's give it a try. Let's go to our servers page component over here, and we can see that server is offline, right? So this is no longer hard coded in the HTML part. It comes from our variable, right? As I mentioned, implicit razor expression can be either a variable or a statement. So let's say I have a space here, and then I'm going to say at followed by another implicit razor expression that is going to show us the time. So I'm going to say date time, and then I'm going to say now. Now I have two implicit razor expression here. First one is using a variable, and the second one is kind of using a statement. And as you can see, a razor expression cannot have a space. So once you have a space, then the rest of the things are considered as HTML. So the at is considered as HTML. And then here, when I have another @ sign, then everything else, as long as there's no space, this is considered as implicit razor expression. So let me give it a try. I'm going to go over here and click on Restart Application. And let's take a look at this and see we have server is offline at the time, and this one is the same. So this is the basics of implicit razor expression. Now let's create a server class to represent the server. So let's go to our server management project here and create a new folder, and let's call it models. So we're going to have the classes created under the models folder here. And I'm going to have the server class here. And we're going to add some simple property. For example, we can have server ID is online, which represents whether the server is online or offline, and then the name and which city the server is located. And for now, I want to randomly generate the status, which is whether it's online or offline. Okay. So I'm going to generate it from the constructor here. We're using our random class here to generate a number between 0 and 1. And then we use that number to generate a Boolean value, whether it's false or true. So now let's come back to our server component here. So here, instead of just use our status variable, let's remove this, and let's remove this as well. So here we are going to have our server class here. This requires our namespace, and as I mentioned before, I'm going to centralize that namespace inside the _imports component here. So I'm going to say server management.models, so that later when I add more classes into the models namespace, I don't have to import namespace every single time. As you can see, that immediately that fixed our problem here. I'm going to just initialize it right here, and then over here I'm going to give it a name server1, and the city is Toronto. And here I'm going to use razor expression here and say @server.name, and I'm going to use a space here. So is in, and then I'm use another implicit razor expression here. I'm going to say server.city. All right, so let's give it a try. Go over here and restart our application. And let's come over here. It says server 1 is in Toronto. This is all I want to show you in this video. You just need to remember that to use implicit razor expression, you just need to start with @. Just remember not to include a space. If you include a space, then the things that after the space is not considered as part of the razor expression anymore. It's considered as part of the HTML. And then you can add another razor expression afterwards. Another thing I want to make it clear is that you don't have to use razor expression inside a paragraph. You can use it in a div, in a label, in a span, in any HTML element. You can even use it in an attribute of an HTML element. For example, I'm going to say data-name equals server.name. Okay, so this is also valid. So let's give it a try. And now you see the same thing, but let's examine the HTML here. And you can see that we have a div and I have an attribute and it has server1 inside it. So that's what I want to show you, right? You can use your Razor expression everywhere inside HTML, including inside a elements attribute. Okay, so that's the end of this video. If you have any questions, please let me know. If not, I will see you in the next one. In this video, let's talk about explicit Razor expression since we have talked about implicit Razor expression in the previous video. Let's jump back into Visual Studio here, and we have mentioned that a implicit Razor expression starts with an @ sign and there cannot be any space. As soon as there's a space, then this part becomes HTML. So this limits the capability of the Razor expression. We cannot do any string concatenation or any logic that we want to put it here. So for example, inside the definition of the server class here, we have this is online here. I want to display whether the server is online or offline in here. So for example, I want to say that is online if the server is online. Otherwise, I want to say offline if the server is offline. So how do I do that? So with the implicit Razor expression here, it's impossible to do that kind of logic there. But with explicit Razor expression, we can do that because the explicit Razor expression also starts with a @ sign, but it has a parenthesis. So therefore, within the parenthesis, you can have space. Because of that, you can do a lot of things with the explicit Razor expression here. So in this case, we can say server.isOnline, okay? And then if it's online, then we're going to display online. Otherwise, I'm going to display offline. Okay? So this whole explicit Razor expression generates a string, and then that string will replace this expression and display it as part of the HTML. So let's give it a try. And let's go over here and refresh the page. So we're going to see server1 is in Toronto, that is online. So it worked. Just like the implicit Razor expression, you can put it anywhere in the HTML. The explicit Razor expression also can be placed in many different places. For example, you can place this inside a attribute as well. So let's add another attribute. Let's say data status equals, and we're going to say server is. We can use the expression right inside here. Let's copy this and paste it here. And then we are populating the status. Okay, let's give it a try. Let's check our HTML. Now you can see that we added a data status attribute and it says the server is online. Just bear in mind, you can use any C# expression inside the parentheses. You can concatenate strings inside it. You can use string interpolation inside it. You can use anything. Anything that is part of C# expression will be valid inside the parentheses here. I want to give another example. For example, if the server is online, I want to show everything in green. Otherwise, I want to show everything in red. So for that, I can modify the font color. Right? So I'm going to say color, and then we can add the implicit expression right inside here. Obviously here, I'm going to change it to green, and this one, we can change it to red. And let's restart the application again and try to see the changes. All right, so we have one that is offline and the other one is online. If I control F5, this time I get both of them offline. And if I control F5 again, this time this first one is online. So I use this way to generate the style, which is very good. You can use another way to generate the style. So let's change this. I'm gonna use the explicit Razor expression to generate the whole style here. So I'm going to use a string interpolation, and I'm going to say color, and here inside the bracket, I'm going to use this, and I need to add another bracket here. It's green, and this is red. And this is going to work the same way as before, but you can see that the explicit Razor expression has a lot of power, right? You have a lot of options. As long as it's a valid C# expression, then you can use it inside the parentheses. All right, so we are having the server's page rendered correctly, and that's everything I want to cover for this video. If you have any questions, please let me know. If not, I will see you in the next one. In order to continue with our server management application, in this video, we are going to create a static servers repository so that we can work with some data. So we can do that inside the models folder. And let's create a class, and let's call it servers repository. And I've prepared some code already, so I'm going to just copy and paste that over here. And then I'm going to go through this quickly with you. So we have some data seated here. We have 15 servers. And then we have a add server method, a get servers function, get servers by city function, get server by ID, update server, and delete server, and also search servers. So let's go through that quickly. Add server, here we're just getting the maximum ID, then populate that server and add it. Right? Add this object to our servers variable here. Now, get servers is very simple, just return all of the servers. And get servers by city, we're using link to query the servers variable, and we're using equals to compare the city name, and we're getting the servers that belong to the city. In get server by ID, of course, we're doing first or default. Again, we're using link. And if it's not null, then we are going to create a new server object. Here's pretty special because if we just return this server, then anything that is changed inside this variable will also change the corresponding object inside this server's list. So that's not something I want. Therefore, I'm creating a new server object and just populating each one of the properties. Update server is quite obvious. Delete server also. And search servers, we're just using contains in the link function here. Because this is a static class with a static variable here, so as long as the application is running, you are going to have this variable accessible in your application. But every time you start the application, it's going to return back to 15 items. So this is kind of a in-memory data store. Later, we're going to work with actual database, but for now, for teaching purpose, it's better to use this static in-memory repository so that we can focus our energy on learning Blazor. That's everything I want to cover in this video. I will see you in the next one. Previously, we are able to use Blazor syntax to render HTML with C# expressions. What about control structures like looping? In this video, we're going to learn how to use looping to output list inside our Blazor component. So let's go into Visual Studio and let's go to our servers page component. Currently, we placed two server components inside it. So let's remove it, right? Because we want to dynamically generate this list. But for now, we're not going to use our server component. For now, we're going to use Blazor syntax to loop through a list inside our static repository. First of all, in order to loop through a list of servers, we need to have a variable to store that list of servers. So we can declare a variable here. We're going to say private, and then we can have a list of servers. So I'm going to just say servers. And we can just initialize that with our static repository here. So I'm going to say servers repository, and we can just get servers by city. We are going to get servers from the city of Toronto. Okay, so now we initialize this. We need to use Blazor syntax to loop through this and generate a list. For a list, we can have an ordered list. And then we just need to have several LIs. So how do we generate the several LIs? We can use for each. And to use for each, as in C#, we can write for each. But when you write it this way, it's considered as HTML. Then how do we fix that? As you guessed, we use the @ sign. Once we use the @ sign, this is considered as C#. Right? And then you just write C#. So I'm going to say var server in servers. And then I have brackets. Remember, in Blazor syntax, when you use control structures, you have to use bracket. You cannot omit them. Although in C# you can, but in Blazor syntax, you cannot. So always remember to write your curly braces for control structures. And then you just place your li inside it, right? Whatever the HTML elements that you want to repeat, then just put them inside the for each loop. Of course, you can use for loop, you can use while loop, you can use any loop that is valid in C# can be placed inside this HTML section here, as long as you start it with the @ sign. So then here inside this list, we want to see the server's name, maybe the server city, and the server status. And how do we do that? We can use the things that we learned, implicit user expressions and explicit expressions, right? So for example, the name here, we can say server.name, and then followed by HTML, so English word in, and then followed by city name, followed by the word is, and then explicit user expression here. You say server dot is online. If it's online, then we're going to say online. Otherwise, we're going to say offline here. So this is all good. Again, I want to output in different colors. If it's online, I want to show green. Otherwise, I want to show red. But this time, I don't want to modify the color of this whole line. I just want to modify the color of this online and offline English word here. So for that, maybe we add a span here and then put this inside the span. And then we can modify the style attribute here. And we say color, colon, and then again, explicit user expression here, can put us inside. And this is going to be green, and this is going to be red. Now this is too long, so maybe perhaps we can format it a little bit better like this. Just make sure that there is a space here, and that's it. So we can restart our application, and let's go over here. And we can see that our server 1, 2, 3, 4, so all the servers in Toronto is rendered and they're all online. And no matter how much you refresh them, they won't get offline because all of the servers are stored and generated in the static repository. So let's go over here. So this is run when the application starts. In order to get a different status, you will have to rerun the application. But anyhow, you know that we have 4 servers inside Toronto, and all of them are being displayed right here. So in order to see different status, we can close this application and restart the application. And now if I go to /servers, now you can see we have one of them offline and the other 3 online. So you have learned how to use C# loop to generate a list. Right? It doesn't have to be UL and LI. It can be any HTML element that you want to repeatedly render. Whenever you want to repeatedly render any HTML element, you can use a loop and then just put the HTML element inside it. And then inside that element, you can use different user expressions to express yourself and generate the HTML that you want to generate. Okay, that's everything I want to cover in this video. I will see you in the next one. This video is an assignment video. We're going to output city buttons. So let's go into our current application. We have a list of servers. Currently, we're hard coding Toronto. So we're only showing servers under Toronto. Eventually, I want to have a list of buttons that represent each city on the top. So when you click on the button, then you're going to see the list of servers that belong to that particular city that you clicked on. So for now, we are not going to implement that filtering functionality, but in this assignment, I would like you to implement the list of cities because you have just learned looping with Razor syntax. So this assignment is to practice to use loop Razor syntax. To get the list of cities, I'm going to provide you with a static cities repository, and that is, I'm going to create it right here under the models. So right click on it, create a new class, and I'm going to call it cities repository. And I pasted the code that I prepared for you. So as you can see, it's very simple. We just have a static cities list variable here with some hard-coded strings here. So we're going to deal with bigger cities inside Canada. And we only have one function here, which is get cities. You're going to use this function to return the list of cities. And then you're going to use Razor syntax to output the list of cities as buttons on top of this list, right? On top of this list, perhaps on line 6. All right, that's the requirement for this assignment, and please work on that yourself. And in the next video, I'm going to present my answer. I'll see you in the next one. In this video, let's work on assignment number 1. I'll put the city buttons. Let's jump into Visual Studio now, and let's come to this server's rootable component here. And we want to output the city list right here. In order to do that, we need to, first of all, have a state variable, just like the servers. The reason why I call it state variable, I'm going to talk about that later when we add interactivity to it. But right now, let's just call it state variable. And this is going to be a list of strings. And it's going to come from the cities repository here. And we can call this getCities method. And with the cities state variable, I can use it to loop through the cities. So I'm going to say for each city inside the cities variable, and don't forget the curly braces. Now I can output buttons. So I want to repeatedly output buttons. I can just use button, but let's try to see how it looks like if I just use button. And the type is going to be button. And I'm going to use Bootstrap class. So btn primary, for example. And then inside here, I just need to output the city name. I have to use implicit razor expression here. So add city, that's it. I believe if I do it this way, all of the buttons will be connected. So I'm going to add mbsp, which is a space. And when I do it this way, you can see that it doesn't like it. The reason why it doesn't like it is because it's thinking that this is like a C#, right? So you can see this error message here. It's trying to consider it as a object or expression. So therefore, in order to make it work, we can tell Blazor that this is actually text. So by using this text element here. All right, so let's run the application and see how it looks like. All right, let's go to servers. And we have Toronto, Montreal, Ottawa, Calgary, and Halifax. So it actually looks not bad. So let me add a line break. Let me add another one to restart the application again. Now I have a better line break here. All right, so with the space in between, what happens if I make it smaller? You can see that the buttons stay together. And I think it would be better if the button would kind of collapse a little bit and stack on top of each other once you make the screen smaller. In order to implement that, we're going to use Bootstrap class, the row and columns. So outside it, I want to use a div. This div will have a class of container fluid. This is not a Bootstrap course, so therefore I'm not going through this in detail. But this div is a container, and I want the text to be centered. And then inside it, I want to have a row. So therefore, I have a row, and I want it to be smaller. So W50, so the width is 50%. And then inside it, I want to have each button as a column. I'm going to say column. And then I'm going to place the button inside here. So that way I don't need to use this space here, right? And I need the column inside the for each loop. So I'm going to cut this over here. Perhaps I don't need 2 line breaks now, so I already have a div. Okay, so that's what I think I need. So let's restart the application, see how it looks like. Okay, so I have bigger spaces here, but the good thing about it is that if I make it smaller, you can see the button changes position and start to stack on top of each other. I think that's what I want. Currently, when we click on the button, nothing is happening, and that's not a problem. Later, we're going to add interactivity to this, and we're going to filter the servers list. For now, this is all we need to do for this exercise, and hopefully you have done it yourself. And don't worry about the Bootstrap part. It's just some style that I want to add into this course. All right, that's everything I want to cover in this video. I will see you in the next one. Before we go any further to learn about components in Blazor, let's see how Blazor handles static resources. And when I say static resources, I mean those images, JavaScript, style sheets, And in the previous videos, we have seen this diagram, and we know that for Blazor, a request is mapped to the root component, and then the router component is responsible for looking for the components and place them inside the root component. But what about the static resources? For static resources, they're mapped directly to the resource itself. Whether it's image or style sheets or JavaScript files, it's mapped directly to the file itself and then displayed inside the browser. And what's responsible for that is, let's go inside
Visual Studio here and let's go to program.cs. And if you remember, this app object is used to configure the middleware pipeline. And each one of these is considered a middleware. So for example, this one is responsible to map HTTP requests to our Blazor, whereas this map static assets is responsible to map HTTP requests to our static resources. So this middleware will help us to map
the request that looks for static resources to the static resource itself. And in Blazor or any type of ASP.NET Core applications,
there is a specific place where you need to place your static assets. So let's take a look. That's this www root folder, and you can create a subfolder under it, or you don't have to. Once you place your static assets inside the www root folder, this map static asset middleware will be able to map the request to the static resources located inside the www root folder. And in order to practice working with static assets, what I want to do is,
let's take a look at the current application here. I want to show a picture about each button, and those pictures will be corresponding to each cities. And I have already prepared the images for you. So I'm going to copy and paste that into our www root folder here. Okay, I have done that, and you can see that I have images folder right here. And if you open it, I have the images that corresponds to each city. And you can see that I have the images right here. So I will be attaching these images under this lesson so you can download it and practice yourself. What I need you to do is to display the corresponding picture for each city just above the button. Maybe pause the video and try to do that yourself and then come back and see how I do it. So let's go to the servers component here. This is the page component, and we're displaying the cities right here. Inside each column, we have this button. So all we need to do is to place an image above this button. But in order to make it look pretty, I'm going to use Bootstrap. I'm going to show you how to use a Bootstrap card. Maybe this is also beneficial to you, but you don't have to use Bootstrap card if you don't like it. So I'm going to show you how to use it. So let's go to Bootstrap and let's go to the documentation here. And if you scroll down to the component part, there is a card section here. And the card section shows you a simple card like this. You can place image on the top. So let's copy this HTML into clipboard, and then let's come over here and try to use it. So let's move this button inside. So I'm going to replace this card body here. All right, just put the button inside here. And we are going to render our image right here. So here, for the source attribute, this is where you need to use razor expression. And because you need to do a little bit logic here, therefore you are going to use explicit razor expression. So the city name is right here. Think about how you're going to do it. We're going to do a @ and a pair of parentheses. So inside it, we can use string interpolation to target the images folder, because our images are inside the images folder under www root. And because it's a root folder, so you're going to start with /. This signifies the root folder, and then images. And after that, we're going to have curly braces to do the string interpolation, and we can just use city inside here. And after this string interpolation, I'm going to put the extension name, because each one of this image is a PNG image. And I think that's everything we need here. Let's restart the application and see how it looks now. So it looks pretty big, and that's probably because it says the width. So let's delete this and see whether that fixes our problem or not. All right, that fixed our problem. This looks pretty good. And that's everything I want to cover in this video. I hope you had fun playing with images. And if any questions, please let me know. If not, I will see you in the next one. This is assignment video. You have learned about rootable component, but you have never had a chance creating a rootable component. So in this video, I would ask you to create a rootable component, which is a added server component. Right? You can call it added server. And then you just need to use the page directive to specify the relative URL for your rootable component. And then what you need to do is to set up a link between the server and that rootable component, right? So for each one of these servers, you need to have an added link. You can use Bootstrap link button to style the link. And then when the user clicks on the link, it should direct the user to your rootable component. In other words, all of these will be replaced by the content of your rootable component. Don't worry about that your rootable component is empty. It may just have a title, but that's okay. That's what you need to practice. Okay, I will see you in the next one where I'm going to show you how I do it. In this video, let's work on the assignment number 2, create a rootable component. So let's jump into Visual Studio and let's start creating the rootable component. A rootable component is considered as a page. That's why it's also called page component. So you can right click on the page folder and then add a Blazor component. Like I mentioned before, a Blazor component is technically called a Blazor component. And because it's a rootable component, I don't want to keep the suffix component here. So just delete it. And I'm going to call it added server. And automatically it creates a title for me. I can add a space here for now. And do you remember how to make a component rootable? That's by using the page directive. So I'm going to say add sign page followed by the URL. So URL here, I'm just going to say servers and /edit. Right. For now, I'm going to use the added word. And later when we learn about parameters, we're going to replace this. Okay. And the second requirement for the assignment is to have a link from each one of the server to this new rootable component. So let's go to servers page component here and let's look at this list of servers here. So we have a li element. Here I can add a space here, and after that I can add this link here. So it's going to be a anchor element. So href is going to be pointing to our added server rootable component. So / and servers and edit. The class here is going to be btn and btn link. So this will look like a link. Inside the element here, we're going to spell out the word edit. And let's give it a try and see how it looks like and how it works. All right, we have a space here and we have a edit button right here. So when we click on it, it takes us to this rootable component. And if we go back, click on another one, we see this. So every single one of them takes us to this edit server component. Eventually we're going to implement this. Right now it's empty and that's fine. Let's take this chance to actually add a link right here, because every time you want to go to the server's page, we have to manually enter it. So let's try to fix this. Do you still remember where this comes from? Right, the left hand side is a sidebar. So it is located in our layout folder. And then if we go to our main layout, we can see our sidebar, but this sidebar is a component. So if we right click on it and go to definition, it will take us to the place where the component is defined. And that is actually still in the layout folder. It is nav menu component. And if you pay attention here, we have nav link. Each one of them goes to a different place. So this one goes to the home component and this one goes to the weather component. And how does it do it? It uses the href, go to the relative path. So what we can do is we can copy and paste. And then this one, we're going to call it servers, or let's call it manage servers. And this is going to take us to the server's path. You can do it this way, or you can add a slash here. it should all work. Okay, let's run the application again just to verify that everything works as expected. We see this manage servers link right here, and we can still go to weathers, come back to manage servers, and go to edit, and come back over here. Okay, that's everything I want to show you in this video. I will see you in the next one. In this video, we're going to learn about root parameters and root constraints. In the previous video, we have created a rootable component, which is this added server component. We are able to navigate to it, but we don't know which server we're editing. From this servers page, we need to be able to pass a server ID to this rootable component, and that's what we are going to do in this video. Now, the way to pass information from one page to the next one is by using the URL here, and that's called the root parameter. For example, if I want to edit server number 1, I can go to servers/number1. It should take me to the edit server screen, but right now it shows me not found. That's because there's no page in our application that accepts this URL. Currently, in our managed servers, no matter which link you click on, it always go to this servers.edit. So that's one of the first things we want to change, right? So this has nothing to do with root parameters yet, but let's prepare our application. Let's go to our servers.razor page component here, and currently we're using this URL. So in order to pass the correct URL over to the next page, we need to do /servers/the server ID. We can use implicit Razor expression here. I'm going to say server.server ID. By doing this, if we rerun our application, we have our application ready for working with root parameters. So let's go back to manage servers, and if we hover our mouse over the edit button, you can see at the bottom left corner we have /servers and then / the correct ID. But if I click on it, then it goes to this not found page. That's why we need to make our edit server page accept this parameter, and this is called a rootable parameter. So let's go to edit server component. Currently, it's accepting this URL pattern. We need to make it accept the root parameter. So the way to make the URL part accept the root parameter is to use the curly brace. And then you can even see that the curly brace change color. And here, you want to call it, you can call it anything, but here I want to call it ID. And then in the C# code, this part of the section that says add code and then curly braces, this is the C# code block. You work with C# in this code block. So this code block cannot have any HTML. And in here, we need to map this to our C# property. And therefore, we're going to create a C# property. Here, I'm going to use string type because I did not specify what type this is. So therefore, I can only use string type because string type can accept anything, right? So here, I can call it ID this way. So with lowercase I, or I can call it ID this way with capitalized I. As long as they match letter by letter, then they match. So that means this property should be able to accept this parameter. So here it's just complaining that it's a non-nullable, so we can add a question mark to recognize that this ID sometimes can be null. Okay, so by doing this is not enough. We need to also use a C# property here to decorate this property and saying this is a root parameter. So there are two things you need to pay attention to. The first one is that the parameter name should match case insensitive. And then the second thing is you need to use the parameter attribute to decorate your property. We had everything ready. So now we just need to display the ID here, just to see whether we actually can accept the parameter or not. Okay, let's give it a try by rerun the application. And let's go over here. So automatically it's already showing number 3 here. Right? So let's go back to manage servers. Let's click on the first one. Now it's showing number 1 and number 1 here. That means our C# property is accepting this root parameter correctly. Okay, let's try another one, number 4. It's showing number 4. That's the concept of root parameter and how to accept the root parameter with our C# code. That's pretty good. However, if I do something like, let's say I change URL back to edit and I hit enter, I see edit. That's pretty weird because I'm expecting integer here. It should not actually accept any type of string. It should only be integer because I want to just pass in the server ID here. So that comes to our second topic here in this lecture, which is root parameter constraint or root constraint. So a constraint will limit the type of the root parameter here. Currently, it is just string. Now we use string to accept everything, but sometimes not ideal. In this case, we don't want to map this rootable component to /servers/anything. We just want to map it to /servers/integer number. So we can use a root constraint by saying colon, and then you can see there is already a list of type that you can use for limiting the root parameter. In our case, it's going to be integer. And after we change this to integer, we also need to change this type to integer in order to match these two parameters. And now we can rerun the application and see what happens. All right, so let's go to manage servers and let's go to edit. So we're still able to map to the correct URL here.
However, if I go /edit, I see this not found page again. That's because this edit is not an integer. It does not satisfy the root constraint. Before we finish this video,
I want to show you this Microsoft documentation, which is talking about the root constraint, and it gives the list of types that you can use for root constraint. It's not any type, it's just these types because you don't want to pass in very fancy data through the URL anyways. Another concept I did not cover is optional parameters. So for example, here is a root parameter, and if you want to make it optional, you can use a question mark here. When you use a question mark here, you don't have to specify this. If you only specify this in the browser, it's going to map to this component. But if you do specify this, it's also going to map to this component. It just means that one has text, the other one does not have text. Okay, that's everything I want to cover in this video. If you have any questions, please let me know. If not, I will see you in the next one.
in this video, we're going to learn to use onParameter set lifecycle event to receive parameter values. So in the previous video, we are only displaying the parameter value on the component, but that is too simple. We need to use the parameter value, for example, to load the information about the server. Because we are editing the server, we're passing in the ID. We need to use the parameter value of the ID to load the information about the server and then display the server information on the screen for the user to edit. So then how do we use the parameter value? When the parameter is passed in through the URL to the component, and after the component is created, there is one lifecycle event that is triggered when the component receives the parameter value. And that lifecycle event, if we use override and then space, then you can see these are all of the lifecycle events we can override. The lifecycle events that I'm talking about is either the onParameter set or onParameter set async. If you're going to make asynchronous calls inside the event handler, then use the async version. Otherwise, you can use the synchronous version. Okay, we're going to talk more about lifecycle events later in the course, but for now, let's override this. So onParameter set is triggered when the component receives the parameter value from the URL. You don't have to call this base class method. This is not necessary. So let's delete this. Here, it is guaranteed that we're going to receive a parameter value. So this is the place where we can use the parameter value to do the things that we want to do. In this particular case, we're going to load information of the server that is referred to by the ID. So then here we can say server repository dot get server by ID. And then here we can say this dot ID. So this will return us the server object here. And for that, we can create a private member here and call it server. And afterwards, we can assign this value to it.
and finish that with a semicolon here. Like I said, inside the onParameter set, we receive the ID, then we use the ID to retrieve the information about the server. Now we know we have a server object here. So here, instead of just displaying the ID, we can delete that, and then we can write implicit Razor syntax here. So @server.name, for example. Let's actually use a paragraph element and put this inside, right? And then maybe another paragraph. And this is regarding the city. And perhaps we're going to show the status as well. So server.isOnline. Now, as you can see that we have this green squiggly line because it's possible that the server is null. In order to make sure that we don't encounter null reference issues, we can use a if statement here. So here, just like writing implicit Razor expressions, we can say @if. So this is C#, and then we can have our condition. So the condition is server is not null. And don't forget brackets here. The curly braces are very important. So you cannot omit that in Razor syntax here. So put everything inside here. So therefore, we're going to render this only when the server is not null. Now you can see that green squiggly line is gone. And let's run our application. Let's go to our manage services screen here. Let's edit maybe the second server. Click on edit. Now we come to here and we can see server name, city, and online status, which is false. So that means we're able to pull the server information based on the ID. And that means our onParameter set is triggered after the component receives the parameter value. Like I mentioned before, you can also use the onParameter set async version, and you can use this when you need to call asynchronous method. So for example, this one, currently it's a synchronous method. So if we have an asynchronous method, then we need to override this asynchronous onParameter set instead of this one. So let's delete the second version because we are only having a synchronous method. While we are on the page, let's also create a close button here so that we can navigate back to the manage servers screen. So let's add a line break here. We can use just an anchor element, and so that we can navigate back to the manage servers component there. So our manage servers component, if we take a look at here, it is the servers.razor, and the relative URL is just /servers. So here we can say /servers, and then we can just use bootstrap class to pretend that this is, instead of an anchor, this is a button. So we can use primary, and text here is just close. All right, so let's run our application again, just to make sure that we have our close button properly placed. All right, we see our close button here. If I click on it, I come back to the managed service component here, and then let's try maybe server number 3, and we see server number 3, and all of the information is correct. Close this, maybe try server number 1. So we tested, everything is working, and this is what I want to cover in this video. If you have any questions, please let me know. If not, I will see you in the next one. In this video, let's learn to use form and input components to display and collect data. So in order to submit data back to the server, whether we're dealing with traditional web applications or Blazor applications, we need to use some sort of forms. Traditionally, these forms and form fields are implemented with traditional HTML form fields like this, with form elements and input elements and a submit button. Here, because Blazor is component-based web application framework, therefore, instead of just using plain HTML elements, Microsoft has some built-in components for us to use. Instead of using plain HTML form, here in Blazor, we can use edit form, right? So edit form is a built-in component, which has a lot of functionalities taken care of for you. And instead of using all kinds of input HTML fields, we have input text, input number, input checkbox, and a whole bunch of other input components that are built in for us to use inside the edit form component. So in this video, we're going to learn how to use these components together in order to create a form to display data and collect data. And then in future videos, we're going to learn about submitting the data back to the server. So let's jump into Visual Studio and get started. We're in our Visual Studio and we're looking at this edit server page component or rootable component. We are going to place our edit form component right here. So we can remove this and we can start using our edit form component. Okay, so this is a built-in component. You can see IntelliSense already telling us it's coming from Microsoft.ASP.NET Core component.forms. We're going to use this edit form component to represent the HTML form. Eventually, it's going to generate a plain HTML element, but by using this, it's going to save us a lot of energy for a lot of different things like data validations and all sorts of other things. So let's start using this edit form component. So we're going to close that. And for the edit form component, so what are we editing? We're editing data. So here we're going to specify the data context for the edit form. And what are we going to do? We're going to use the model attribute here to specify the model object for the form in order to say, hey, this form is going to work with this data. Right? So here we're going to specify the server. I think we deleted something that could be necessary. So let's copy this and revert this back to what we had before. You see this if statement? We're going to actually keep the if statement here so that we know that when it comes to the edit form, the server is not null. And then inside the edit form, we're going to have special input fields. Like I mentioned here, we're going to use special input components to replace the regular input element. So here, for example, we are dealing with the name field. And we can use input text because the name is a text. And for now, we're going to display the data from the server object. And the way to do that is to use this server attribute here. So @bind value. So remember, this is a capital V. If you use a lowercase v, it's not going to work. @bind capital V value. And this is going to bind to our server.name. And we're going to have next field, which is city. So we're going to say .city. We're going to bind the city property to the input text. And again, over here, we're going to use input checkbox, right? So this is going to bind to the server.isOnline, right? Because the isOnline is a Boolean, and the checkbox can be used to work with a Boolean property here. If we have all of this, and if we run our application now, let's go to manage servers, click on edit. And now we're having input box, and a checkbox here. So we can see that we have the data properly populated. Click on the close button, check the number 2, server 2 Toronto, and it's checked. Number 3 is offline, so it's not checked. So it looks like everything is working. So now we're going to use Bootstrap classes in order to represent the forms correctly. So let's go to Bootstrap and go over here. Click on Documents, and let's scroll down to Forms over here and Form Controls. Okay, so we have different ways to formulate it. So you can read through this, but I have prepared my code, so I'm going to copy and paste that over. All right, here is my prepared form views layout with Bootstrap, and we have 1 row and 2 columns with different size, and here's the label. So for this one, we're going to use name, and we're going to move this input text over here. Okay, and we're going to duplicate this for the second field, which is city. And here it's going to be city. So let's remove this. And finally, let's also duplicate this. Here we can say online, and we're going to change this one first to input checkbox. And this one is going to be is online, and we can remove this down here. Now we need some CSS classes for the input components. Class and form control, and we're going to copy this and paste it over here. And for this input checkbox, we're going to use form check dash input here. And let's do a hot reload and see how it looks like. All right, let's go to manage servers, click on the first one, and we have everything populated correctly. We have our CSS styles applied properly. And let's check the fourth one. We have online unchecked. So everything is working. This is all I want to cover in this video. In this video, you have learned to use the edit form component to represent a form. And one of the most important part is to use the model attribute to represent the data context, right? The data context for the form. Inside it, we use different type of input components here. We have input text, we have input checkbox. Let's go over here, let's try to do this. And you can see we have all kinds of different input components here. We have dates, file, number, if we need a field for number, radio button, if we need a radio button, a text area, and select. So this is like a drop-down list. You have different options. Depending on your need, you can use different things. Here, we are using input text and input checkbox just for example, and in your own project, you can use those fields. All right, that's everything I want to cover in this video. And if you have any questions, please let me know. If not, I will see you in the next one.
In this video, we're going to learn about form submissions in static server-side rendering.
In the previous video, we learned to use edit form and special input component to collect user data. In this video, we're going to learn how to submit data. Specifically,
we're going to learn about form submissions in static server-side rendering.
Because once we add interactivities, the process is going to be different.
Static server-side rendering is very similar to
traditional web applications, where form submission is just through regular form submission. Let's take a look at the diagram here that represents a form submission in traditional web applications. So we have a browser and we have a form in the browser, and then we have the server. So this box is just representing the server. And when the user clicks on the submit button, the form fields and its values is going to be submitted back to the server. So the URL, the form values are going to be packed together as HTTP requests and sent to the server. When the server receives the HTTP request, it's going to process that request. And there are two parts that are important for processing the request. One is the function itself, which handles the form submission event. And the other is the parameters or the variables that receive the form field values. Once we have these two things, the developer will be able to code the logic inside the function, handle the values, and do whatever the developer needs to do.
Here in static server-side rendering, we have a similar process.
Right? We click on the submit button, everything is packaged together as a HTTP request, goes back to the server. Now, we also need to have these two things. So let's go into our Visual Studio and see how Blazor implements those two important factors in form submission.
First thing first, static server-side rendering requires
every edit form to have a form name in order to distinguish one form from the other form, one event handler from the other event handler. So therefore, we're going to use a form name parameter here, right? So this is a component and this is a component parameter. We need to use the form name parameter here to specify the name of the form. We can give it any name. I'm going to call it form server because we are managing servers, and here we're editing the server. So that's first thing. Secondly, we need to specify the event handler, right, which corresponds to the function that we talk about, because we need to have a function to be able to handle the form submission event. And for that, in our edit form, we have a onSubmit event handler here, and we can just specify something like submit. You can give it any name as a function name, right? So here I just put submit, and then scroll down to the code block here and then add a function. So this is going to be called submit. And once I have this as a function, scroll up, you can see that the red squiggly line is gone. That means the syntax is accepted. Now we have the function. Then we need to take care of the second part, which is receiving the values. Right? So the values of the form fields need to be mapped to variables or parameters back at the server. Here, we already have a model attribute to supply data or bind data from the server, right? Because we have a variable defined in this server, and this variable is bound to the edit form in order to display the information inside the form. Now, it's a question of receiving the data from the form when the form is submitted back to the server. So how do we do that?
In static server-side rendering, it's very simple.
First thing first, we're going to change this to a property. So that's a requirement. And secondly, we need to provide a attribute here, right? It's a C# attribute. And it's called supply parameter from form. With this attribute, when the form is submitted back to the server, along with the URL in the HTTP request, the Blazor framework is able to find the component, because this specifies the corresponding URL. So it finds the component, and then because of the supply parameter from form attribute, it knows that the data in the form needs to be bound to this property, then it will be able to do that. Now, what if we have multiple forms, right? If we have multiple forms, each form needs to have a form name. And then inside the supply parameter from form here, we can actually specify form name here. You can see we have form name. So we can specify the form name, and this form name will need to correspond to the form name that we provided up here, right? So if we have multiple forms, then each form will have a different name, and then the form name inside this attribute will correspond to different names. In this case, we only have one form, so we don't actually have to specify this. So let's delete it. Now we have already handled the two aspects, right? The two factors of this form submission. We have a function that handles the form submission event, which is this submit event handler here. And we have a property that handles the data mapping, which binds the form fields values back to our server property here. So we already handled those two aspects correctly. With that, we need to just add a submit button because we coded our form here. We did not specify our submit button. So let's do that. Let's add a line break inside the form. And then we can code a button here. So we're going to use bootstrap button, and it is going to be a primary button. And the type is very important, it has to be a submit button. It cannot be a regular button. And here, because we are editing servers, we can say update. And we can also move this inside here, and we can add a space in between, and we can remove this line break here. All right, let's give it a try. Let's set up breakpoint here and click on the debug button here. And let's go to manage servers, maybe go to number 3 here, and let's change online status to online and click on update. Our breakpoint is hit. So that means the event handler is actually handling the submission event. So now the question is, did our server object actually receive the form field values? So let's take a look. So quick watch is online is false. So we did not actually receive the form field value here. Actually, that's not true.
What is actually happening here is that when the submit button is clicked on, the form is submitted back to the server side. And then this supplying parameters from form happen first. Therefore, this property is actually assigned with the value from the form first. But then this onset parameters happens again, which overrides whatever the value that received from the earlier process over here. Therefore, when we are examining this variable, we're looking at the original value from the server's repository here.
In order to avoid having this issue, we have to make sure that we do not populate the server again if the server object already has some value. So in order to do that, we can use this double question mark. What this means is that we're only going to use the static repository to retrieve the server data if the server is null. If the server is not null, the right-hand side operation will be skipped. So let's try to do that again. Let's run the debug. Go to Manage Servers. Let's try to edit server 1 and click on Online and click on Submit. Now the breakpoint is triggered. Let's watch what we have in the server variable here. And this time you can see is online becomes true. That means we are actually receiving the form views. So those two important aspects of form submission, we have done that, right? We have our function that is triggered, and we have our server property that contains values from the form, right? So this is triggered, and our server variable here actually contains the value comes from the form. So let's continue this, and let's close and come back to maybe server number 4. Let's say I'm going to change this to 46 and change this to Toronto 1 and online. Click on update. Now let's examine the server variable here. We have server 46, Toronto 1 is online, is true. So clearly we have received the value from the form submission. We just need to code our logic inside the submission now. There is just one problem here. Let's watch this again, right? Quick watch. You can see the server ID is 0. Okay, so whatever logic that you're going to put under the submit event handler here is not going to work because we don't know which server we are going to update because server ID is 0. So therefore, in the form, we need to add something. So let's stop this, and we need to add a hidden field here in order to submit the server ID back to the server when the submit button is clicked on. So let's add it at the top or at the bottom, it doesn't really matter. I'm going to say input number because ID is a number, and we're going to bind this to, again, to server dot, but this time to server ID, and this is going to be a hidden field. So I'm going to put hidden here, and that's it. Right, so with this change, let's run debug again. Now go to manage servers, maybe add it number 4. So again, I'm going to change to 46. This is to Toronto 1. Click on this and click on update. Now let's examine the server variable here, and we see that everything's changed. We also received server ID, which is number 4. Everything looks correct. Now we just need to code the logic inside the submit event handler here in order to update the server. And that is very simple. First of all, we're going to check whether the server is null or not. If it's not null, we're going to perform the update. And we're going to use the server's repository. And I'm going to say update server. We're going to provide the server ID, which is server.server ID. And then we're going to provide the server object here. And that is it. So let's run our application again. Go to manage servers. This time let's add it number 2. And let's change number 2 to offline. Maybe we're going to change this to server dash number 2 and click on update. Looks like nothing is happening, but because we didn't add any navigation or any stuff. But if we click on the close button, and coming back to the manage server screen here, you can see that the server name is already updated and the status is changed to offline. Right, so if click on edit again, change this to number 2, right, and change this back to online, click on update, click on close. Coming over here, you can see the name is changed, status changed back to online. In this video, we covered how to do form submission. And remember, there are 2 different aspects of form submission, which is the function that handles the submission event and the model binding part, which binds the form fields to the server-side variables.
In static server-side rendering,
those 2 aspects are handled by a submission handler, which can be the onSubmit handler, and there are different onSubmit handlers we're going to talk about later. So you can see that we have invalid submit, valid submit. In this case, we're just using onSubmit, which is fine. So that takes care of the first aspect. And then the second aspect is to receive the data or Traditionally, it's called model binding. And to do that, we use the supply parameter from form attribute on top of the variable. And remember that this is the same variable that is used to bound the data to the form, which is here, right? And then we just need to specify this to receive the data from the form, right? So this is like a two-way data binding from the attribute to the form, and then come back with the help of this attribute. And then inside the event handler, we can implement the logic that we need to implement. And that's everything I want to cover in this video. If you have any questions, please let me know. If not, I will see you in the next one. In this video, we're going to learn about form validations. So let's go into Visual Studio directly. And from the last video, we were working on the edit form and form submissions. And we know that the form's data context, which is also called the model object, is the server object. The type of the server object is the server class here. When the form needs to be submitted, what we need to do is we need to validate each one of these properties of the server object. So therefore, what we need to do is to use data annotations on the server class. So let's go to the definition of the server class here, which we define it right here under the models folder. We have the server class here. And we just need to use data annotations. Data annotations is not part of Blazor, it's part of C#. So for example, we need to say that the name and the city is actually a required field for the server class. So for that, we can use C# attribute, and we can just say required. And right now we see a red squiggly line. That means we don't have the namespace yet. So we can do control dot to import the namespace, which is from the component model.data annotations. For city, we can also say required. It's online because it's a Boolean value, it always has a value. The default value is false, so we do not need to specify any annotations. Let's take a look at the documentation from Microsoft to know a little bit more about data annotations. All right, this is learn.microsoft.com, and we're looking at data annotation namespace here. You can see that what we used is the required attribute, right? It specifies the data field is required. And you can see that we have so many different attributes here that we can use. For example, we can use compare attribute in order to compare two properties. And one of the other very commonly used is the display attribute, which can provide a different name of the attribute or different label of the attribute. We have the string length, which help us to limit the length of the string. Right? So there are different things we can use. For more information, I suggest you to come here and read the documentation. In our case, we can simply just use the required field validation on both of these fields. And once we annotate our model class here, then we come back to our edit form. And in order to make the edit form validate the model object here, right, or the data context here, we need to use a couple of components at least. One of the most important thing here is the data annotation validator. So we just need to put it here. This tells the edit form to actually try to validate the model object based on the data annotations on the model class. And then we need to specify how we want to spit out the error message. One of the easiest way is to use the validation summary component here. And all you need to do is just put it here. And then the summary will appear on the top. Sometimes you want to have summary appear both on the top and at the bottom. So in that case, you can copy this and paste it at the bottom, for example, right here. In our case, we don't have to do that. So let's just do this. And then another thing we need to do is, instead of using onSubmit here, we need to use onValidSubmit. So delete the original, and then we're going to use onValidSubmit. You can also handle the onInvalidSubmit to do some extra processing when the data is invalid. But when you use data annotations along with data annotations validator here, the validation automatically kicks in. So you don't have to handle the invalid submit event. So here we can just use onValidSubmit, and we're going to connect to the original submit event handler defined right here. Okay, let's give it a try by running the application. All right, let's go to manage servers and let's change the first one. Suppose that we're gonna delete the name and click on update. You can see that validation automatically kicks in. The data is not actually updated, so let's prove that is true. Close this. You can see the server name is not actually updated. And come back, we can still see server 1. Right? So suppose we're gonna delete both this and click on update. We have both error messages shows up on the top, and this is from the validation summary component. Another nice thing you notice here is that the border of the input component actually changed to red, and this indicates there are problems with the field. Let's update the server name. Let's actually close this and try to do it again. And this time we make sure that something is actually changed and change this to offline. Click on update and click on close. Now we don't see the server 1 anymore because we changed the city. So we're gonna make sure that we don't change the city. Let's go back to edit number 2, server number 2. So I'm not gonna mess with the city now. So click on online and click on update and click on close. You can see that everything is changed correctly. So this means that our data annotation validation kicks in properly. The validation error message is showing up on the top correctly. There's just one more thing. Sometimes you get a requirement where users want to see the validation error messages right beside each field. In Blazor, that is also possible. So let's try to do that here. So here, because we have for each row, we have 2 columns, we can add another column which just contains the potential error message here. So here we can use the COL class here, which means the width is going to be automatic. And we can use another control. There is a control that's called validation message. And there is a for attribute here. We can use lambda expression to specify which field is to be validated. So here I'm going to say goes to server.name. Because we are validating the server name here, that's why this validation message points to the server name. And we're going to copy and paste this 2 times. So this one and this one doesn't need to be validated because it's a checkbox. It always has a value. So we don't need to worry about that. We just need to change this to city and that's it. And let's rerun our application. And we come back over here and let's say we delete this and click on update. Now you can see the error message shows both in the validation summary component as well as in the validation message component right here. Right. And if I delete this, you can see the city field is required, shows up right here to the right of the field. So just to summarize, in order to provide validation, you need to do a few things, right? First of all, you need to go to the definition of the model class here, and then you use data annotations, which is a feature of C#. Okay? Just use that to decorate each one of these properties. It doesn't have to be required, just refer to the documentation. According to your requirement, what you need to do, just use that data annotations. And secondly, come back to the edit form here. We need to use onValidSubmit in order to handle the form submission event. And then one of the most important thing is that we use the data annotations validator in order to trigger the validation. And last but not least, we need to decide whether we want to just use validation summaries or we want to display error message for each field or both. So in this case, we're using both the validation summaries as well as validation message for each field. All right, that's everything I want to cover. If you have any questions, please let me know. If not, I will see you in the next one. In this video, we're going to learn about Navigate with the Navigation Manager. And we're also going to talk a little bit about dependency injection, because in order to use the Navigation Manager, we need to inject the Navigation Manager into our component. All right, let's get started. So from our previous videos, we are able to add a server. And once we update the server, for example, we update it to -1 and then click on update, nothing is happening. There could be different behaviors when you click on the update button. One behavior is to actually take the user back to the server's component. Just like when you click on the close button, it takes you back. And of course, when you click on update, you first need to update the backend data repository, and then you take the user back. The way that we use on the close button is just a simple anchor link. However, for the update button, if we go to our code here, so this is the code block, this is the event handler here. When the user clicks on the submit button, this is the event handler that handles the submission. And here we only updated the server with the server's repository. There has to be a second step where we take the user back to the servers, the managed server screen. So to do that, we need somehow use C# to take the user from this particular component, which is the edit server page component, back to the servers page component. So we need something that is called Navigation Manager, which is a class within the Blazor framework. So we need to inject that one into it. We're going to talk about injection a little bit later, so let's start using it. So we're going to say add inject, and then I'm going to say Navigation Manager, and we need to give it a name. So typically I just want to call it the same name, so I'm going to just copy and paste it over here. Right? And then I'm going to scroll all the way down here, and I'm going to say Navigation Manager dot, and then we can say navigate to, and here we can specify our URL here. Just the same URL as the close button. So we can just copy this and paste it over here. We can restart our application and try to see the result. As you can see, the application started, server name changed back to server 1. So let's say server.1. Okay, click on update. Now it takes me back, and you can see the server name is updated to server.1. Right, click on edit again. You can see the dot is still here. Let's change this. Click on update, and let's change to offline. Do a Control F5. Everything still stays the same. That means we updated data correctly, and we navigated back to the managed servers page here. All right, now let's talk about this injection thing. What is this inject? What does it mean? Because typically when we want to use a class in another class, right here, you can consider this as another class, right? So here, typically when we want to use any class, we need to instantiate it, right? So what that means is that instead of using inject, we should do something like this, right? So let's say Navigation Manager equals new Navigation Manager. We should do something like this. And then we can use the Navigation Manager to do navigation. Why we are not doing this here in Blazor here? We don't want to instantiate a object from a class within another class. We want to inject that into our class because we don't want to have a dependency. Right? This particular component here doesn't need to know the definition of this class, and it doesn't need to manage the lifespan of this object either. So here, when you instantiate an object, then this whole component needs to take care of its lifetime management. It gives birth to it and also needs to dispose it. Otherwise, there could be a memory leak. Therefore, there is a concept and a technique to resolve this problem, which is called dependency injection. And that's where this inject keyword comes. It represents dependency injection. So what that means is that this component or this class is dependent on another one. In this case, it's Navigation Manager. And instead of instantiate the object from this class directly, like what we just did with the new keyword, we are injecting an instance into this particular component so that the component doesn't need to know the definition of this class, and it doesn't need to manage the lifespan of the instantiated object. And how is that possible? Okay, let's jump into a diagram and let's talk about that. I'm not going to introduce the whole theory about it, but it should be just enough for you to understand how dependency injection works in ASP.NET Core. Let's use this rectangle to represent our component here, right? So this is our component, and we said that we don't want to instantiate a navigation manager within our component, because if the component knows the definition of the navigation manager, that means if there's any change of the definition of this class, this component needs to be rebuilt. That means these two things are tightly coupled. We don't want to do that. We want them to be loosely coupled. So that's one reason. The second thing is that we don't want to manage the lifespan of this navigation manager or any class that you want to use within your component. So to solve that problem, we said that we need to use dependency injection. That indicates that this instance comes from somewhere else. It is injected into a component. Then here's the question. So who is going to take care of those two aspects? Right? Who needs to know the definition of the navigation manager, and who needs to manage the lifespan of the navigation manager? That is our infrastructure. In other words, it's our framework. So our framework needs to have a capability to do those two aspects. In this case, it's our ASP.NET Core infrastructure, because Blazor framework is under ASP.NET Core infrastructure. So in ASP.NET Core infrastructure, we have something, let me temporarily delete that line. We have something that is called a dependency injection container, DI container. This DI container is the thing that helps us to inject any object that we requires from within our Blazor components. In this case, the navigation manager comes directly from the DI container. And it is the DI container that takes care of the injection over here. And the DI container is responsible to take care of both things. It needs to know the definition, and it needs to be able to manage the lifespan. Once it knows those two aspects, it's going to be able to instantiate on behalf of our component and then inject that into our component. So let's take a look at our code here. We register the dependencies like the navigation manager into the DI container in the program.cs. The DI container here is just this service collection here. You see this service collection? This is a collection where all of the dependencies of our Blazor framework is injected, and it's injected through this add razor component function here. So let's actually right click and go to implementation. And in here, we scroll down, we see this add singleton, add scoped. This is basically putting all of the possible dependencies into the dependency injection container. In this case, it's putting it into this services collection. Therefore, it knows the definition of the class. And secondly, you see this is singleton, this is singleton, and this is scoped. These are basically lifetime management. Singleton, that means there's only one instance within the whole lifetime of the application. Right? And scoped means that the instance of the class lives as long as the signal channel. This is related to the server interactivity. Right? So those are the two aspects. We're not going to go too deep into that, but let's pay attention to here. We see navigation manager right over here. So that means on this line, we're putting the navigation manager into our dependency injection container here. And once this is registered into the dependency injection container inside a component here, when we need an instance of this object, the container will instantiate an instance and inject that object into our component. And then we can just use it. After we use it, we don't have to clean it up because the infrastructure, in this case, our services collection within ASP.NET Core, will be able to take care of all of that for us. So this is the beauty of using dependency injection. Going back to our diagram here, the services collection is our DI container, and we just register all of the dependencies that we need into the container. And then when we need it from other places, it doesn't have to be a component. You can inject dependencies into your own classes anywhere that you need. And the infrastructure, which is in this case ASP.NET Core infrastructure, is able to give you the instance of the objects that you need. So this is a quick introduction to dependency injection in ASP.NET Core. And when it comes to The usage, well, you just simply go to your component and use the add inject keyword to inject the instance of the object into your component or your class, right? You need to provide a type and you need to provide a name. You might be asking, well, here you provided the class name, so there must be a dependency already. The component already know the definition of the navigation manager, so why bother? Why can't you just use the new keyword to instantiate it? Well, this navigation manager is an abstract class. So let's go to definition. You can see this is abstract class. That means it doesn't actually contain much implementation. It's almost like a C# interface. The actual implementation of this abstract class is, let's go here again, is actually the HTTP navigation manager. So this is the concrete implementation of this abstract class. So therefore, our added server component is not dependent on the concrete implementation. It's only dependent on the abstract class. And a lot of other registration of dependency injection here use interface. So this is the standard way of registering a class into the container. You use a interface as the type and then followed by the concrete implementation. Here, you use abstract class. This is also another way to register a concrete implementation. So therefore, our component is not actually dependent on the concrete implementation. It's only dependent on the abstract class or the interface. All right, to summarize, in order to use dependency injection mechanism that is built in ASP.NET Core, first of all, we need to register the definition and the concrete implementation into the DI container, which is the dependency injection container. In this case, in ASP.NET Core, it is the services collection here. And this is an extension method that contains all of registrations right here in the method. When we have our custom class, we might need to inject that ourselves. And when we do that, we just do it in the program.cs, or we can create an extension method. So we say builder.services add, and then we can either add singleton, right? And then we provide our registration right here. So usually it's a interface, something like this. So it's either singleton or scoped, right? These are different lifespan, or transient. Transient means that every time you ask for instance, it's going to create it for you. It's not going to store it inside the container. You're basically just registering a interface, which is abstract definition, and the concrete implementation into the container. The container only knows the definition and the implementation. And every time you ask for it, because it knows the type, it's going to instantiate the concrete object for you and inject that into your component or your class for you. So you do the registration right here, right? And then at the place where you want to use it, you go ahead and use the keyword add inject with the abstract class name here or the interface name here, depending on how you registered in the container, and then the name that you give it. And then you can use this name inside your code. So thanks to our infrastructure that managed all of this for us. That's everything I want to cover in this video. If you have any questions, please let me know. If not, I will see you in the next one. This is assignment number 3. We are going to add server because we're able to rate servers. We're able to add a server. Now we want to add a server. And in this assignment, we're focusing on practicing these 3 different aspects of Blazor. First one is adding a rootable component. And the second one is using forms. Here you need to use one form. There's so many aspects of using a form where you need to pay attention to when you're working on this assignment. And last but not least, we're practicing using Navigation Manager to navigate away from a rootable component. Try to do that yourself based on the added server rootable component, and then come back and watch the next video where I am going to show you how I implement the add server rootable component. All right, I'll see you in the next one. In this video, let's work on this assignment, add server. Let's go into Visual Studio because add server is going to be another rootable component as I specified here, right? So this is a specific requirement. So you need to implement it as a rootable component. Of course, in a real project, you have an option to convert our edit server component right here into a multiple purpose component that can be used to edit or add. But because this requirement is specifically asking you to create another rootable component or page component, so you need to do that, right? Because to convert this into a component for multiple purposes, this component is going to be a reusable component, which is going to fall under this controls. And we're going to talk about reusable components in its own section. So here, we just want to practice adding a rootable components and practicing using the forms for Blazor SSR. Therefore, we are going to add a rootable component under the pages folder. Right click on it and select Razor component. And remember, for a rootable component, I don't want to use the component suffix. If you like it, you can still use it, but I'm going to delete everything. And I'm going to just call it add server and click on the add button here. Here, just make it look slightly better, add a space there, and then a line break. Because this is very similar to edit server component, so we can go to edit server component and basically copy everything under this if statement, because we don't need, because this is add server, when we navigate to the page, we don't have a server object yet, so we don't need to worry about whether the server is now or not now, and just paste this over here. Well, this is going to still bind to a server, but that server is something that we are going to create in our code block here. So first of all, we're going to declare a server property like this. And because this is a add servers component, so we don't actually need to get it from anywhere. We just need to initialize it. And when we initialize it, we want to specifically set it to be offline, because this is a new server. It doesn't make sense to add a new server that is directly online. So set is online to false. And then let's examine our form. So in order to be able to collect data from a form, we need to use the edit form component in Blazor. And then we have our model object, and that's our server property here that we just declared. And we can have a form name, and this form name can be the same as what we declared here in the edit server, right? They can be the same, because when the form is submitted, everything is packaged together along with the URL, right? So here, add server is going to have a different URL here. So therefore, that reminds us that the single most important thing for a rootable component is the page directive. And here, we're going to say servers/add. We're going to implement this later, but look at the validations. We want all of these validations here. For this server, we don't have a server ID, and we don't need to submit a server ID because this is a new server. It does not have an ID yet. Okay, so we can delete this. Now, all of these fields will stay the same. We just need to change this to maybe to save. Right? It doesn't make sense to call it update anymore. And then we can still keep our close button here. Now, when the submit button is clicked on, we need to be able to receive the data here. And for that, remember, we need to use the C# attribute, and it's called supply parameter from form. So that makes all of these information bind back to this server property. And last but not least, we just need to define this submit method here that corresponds to this event handler here. And inside it, instead of updating server, now we just need to add server. So here, just to be safe, if server is not now, then we are going to use server's repository, and we can say add server, and we just put the server inside it. So after we add the server, we want to navigate this user back to the server's component here, this one. Therefore, we are going to inject the navigation manager. So inject navigation manager. And again, we're going to call it the same thing and come over here using navigation manager to navigate to the server's component. I think this is it. Maybe we add another line break and let's give it a try. All right, let's go to manage services, and we don't have a button for us to add a server. So maybe we can take the opportunity here to add a add server button. Right, so let's go to the servers component here. This is a page component, and at the very bottom we can use a anchor link, and this is going to go to servers/add. So this is our add server rootable component, and our class is going to be btn primary. So therefore this anchor link will look like a button, and we can just call it add server. All right, so let's run the application again, and we see our add server button here. Let's click on it. Now we go to our add server component here. We know that we only have 4 servers in the city of Toronto, so maybe we can say server 4.1 and then Toronto. Let's keep it offline and click on save button. And this redirects us back to the manage server screen, and we see that server 4.1 is added and it's offline and it's ready for us to add it. So we can come here and turn it on. Click on update, comes back, server is online now. So let's try to add another one, maybe server 4.2, and again it's going to be city of Toronto, and click on online, click on save. Now server 4.2 is online already. I hope you learned a lot when completing this assignment, and if you have any questions, please let me know. If not, I will see you in the next one. In this video, we're going to learn to use edit form to delete data. Specifically, we're trying to manage servers, so we're going to use edit form to delete a server. We need to use edit form to delete server because
We're working with static server-side rendering.
So let's first of all try not to use the form to delete a server and see what happens. So this is the servers component, and this is the server list here. And then we try to add a button here. So ampersand and BSP and add a space. Then we try to add a button here, and let's give it a class. So bootstrap primary button. I'm gonna call it delete. And now we'll try to handle the event, which is onClick event. And inside the event, we're gonna call the delete server function, which we haven't created yet, but that's fine. We can use it and then we can add later. Here, we just need to provide server.server ID, right? So we are deleting this particular server. So here, in order to call a function like this, we need to use explicit result expression. So add sign, parenthesis, and inside it, we're gonna use arrow function, just like this. Finish that with a semicolon, and finish everything with a curly brace here. Now we just need to implement this delete server function here. So we go down, void delete server, and then it accepts a server ID. Now inside it, if the server ID is greater than 0, we're going to use the server's repository to delete the server. So just like this. If we try to run debug, okay, set a breakpoint here and try to run debug, and let's go to manage servers, and we see our delete button right here, and let's try to click on the last one, and you can see whichever button I click on, there's no response. Why? Because this is considered interaction, because traditionally you will have to handle this click event with JavaScript. Here, this is static server-side rendering. It's only server-side. There's no interactivity at all. And we are not using JavaScript, so the button wouldn't work. That's why I said that we need to use a form. Right? We need to use a form, and we put a submit button inside it so that we can use the form to submit the server ID back to the server, right? To the server code block over here. And then we can use this function to actually handle the delete event. For that, let's stop debugging and try to add a form inside it. Here, we are going to use a added form. For added form, we will have to have a model. And this model is going to be the server, which comes from this for each loop. And then the second thing that is required is the form name. And because we're in a loop, If I just say form server, then it's going to create multiple edit form with the same form name. And that's not allowed. It's not going to work when you try to click the submit button. So therefore, we are going to use explicit razor expression to actually come up with different form names based on the server ID. We are going to use string interpolation inside it. So here I'm going to say server dot server ID. This way the form name is going to be unique because it's based on the server ID, and we know the ID is unique. Another thing we need to do is to handle the unvalid submit event, and this is where we can just use this and copy this and paste it over here. Right, so when we submit, we just need to call the delete server function to handle the form submission event. Right? And the server ID just comes from inside as the function parameter. It doesn't actually come from the form field data. And then inside edit form, we need to have a submit button. So we can use this button, cut it and put it inside. And instead of button, the type of the button is going to be submit. And we don't need to have the event handler anymore. So let's delete this. And this is going to be called delete. This is it. Right? So when we click on this delete button, because it's submit button, it's going to submit the form back again to the server. And it's going to use this URL, so therefore it comes back to this delete server function with the server ID provided, and it's going to actually delete the server. Okay, let's try to set a breakpoint here and run debug again. All right, let's go to manage servers, and we see this delete button here. So there is a line break over here, and that's fine. Later, we're going to convert this an order list to maybe a table. So at that time, everything will look better. Right now, we can click on this delete server number 4, click on it, and we can see that this delete server event is triggered. And hover the mouse over it, you can see the server ID is number 4. And that means we got the data, and we can delete the server. So we can step into it and try to delete the server. Now if I continue and we come back, we see that server 4 is still here. Why? It's because the page is not refreshed. So let's say we go to weather and then come back to manage servers. You can see the server 4 is actually deleted. And let's try number 3. Breakpoint is also triggered. Let's continue and come back over here. Again, we got to refresh the page manually now, and we can see server 3 is also deleted. So in order to refresh the page, we can use the navigation manager. And again, to use navigation manager, we need to do dependency injection. So we inject navigation manager into our component, just like this. And then over here,
we try to use navigation manager to refresh the page. And let's try this again. So let's go to manage servers, and then let's try to delete. Let's say we're going to delete the number 3. Click on delete. Now you can see number 3 is gone. We only have server 1, 2, and 4 left. Let's try to delete number 4, and number 4 is gone. Okay, so refresh from the navigation manager works. I remember last time when I recorded this video in .NET 8, I had a problem with this refresh method. Apparently it's fixed. But if it flares up, you can choose to use navigation manager .navigate to. And in this static server-side rendering, we don't even need to use true to force the navigation. We can just use this navigate to. It will still work. So let's say I'm going to delete number 4. And now you can see number 4 is deleted. So this is still work. But since the refresh method is already fixed, so we can try to use the navigation manager .refresh.
This is how we can use edit form to delete a server. I just want to mention that another reason why we use edit form instead of a anchor link, right? In theory, we can create an anchor link and create another page component and redirect, just like this, redirect to that page component in order to run this delete function. When we do that, it's going to work, but it's not a good practice because the edit form, when we submit the form, clicking on the button, submit the form, it's a HTTP post. and the data is not visible. Whereas if you have an anchor link like this, it's going to be stored in the browser history. So people will be able to find the URL for delete server, and they can actually manually type in that URL in order to actually delete your data. So therefore, for deleting data, it's better to use a HTTP post to perform the action for security purpose. Later, when we add interactivity, we don't actually have to use edit form. We can just actually handle the click event like I just showed you at the beginning of this video.
But here, if you just want to use static server-side rendering to complete delete functionality, there's no problem. Just use the edit form to submit the server ID back to the same page. We will have a method, take the server ID in and perform the delete functionality right here on the same page. And then just remember to refresh the page and we are all set.
In this video, let's talk about stream rendering.
So far in our application, we have been using static server-side rendering, and static server-side rendering is very similar to
the traditional application, as you know already, that each time we ask something from the server, it sends a request and come back with a response.
One of the problems with traditional web application, which also exists in static server-side rendering,
is that if there is a heavy load in the browser, then it takes time for the response to come back. And from the user perspective, the user is just waiting.
Let's take a look at how that manifests in static server-side rendering within Blazor.
So let's use the weather.razor page, which corresponds to this particular page, right? The second one here. And if you come over here, you see that it says the stream rendering. The stream rendering attribute is used to resolve this problem. But first of all, let's delete this and see what happens if we don't have it. And let's scroll down here. It says add a half-second delay. Let's actually add a 2 seconds, maybe 3 seconds delay so that it is more obvious. Now that we made these changes, we can run the application and observe what's happening here. So let's run the application and let's go back to home and then come back to weather. So I already click on weather, but I'm waiting, and now finally I get the result. So let's try that again. Go back to home, and now I'm gonna click on weather right now. Okay, I clicked already, but I'm waiting for 2 seconds. Then I get the result. See, from the user perspective, we're just waiting for the data to come back, right? Because these data are generated from the server side, and everything needs to come back and to be rendered on the browser from the response.
You can see this is a problem with static server-side rendering.
Because everything renders statically and everything comes from the response. So therefore, you will have to wait until the home page comes back.
This is absolutely true in traditional web application. However, in static server-side rendering within Blazor, it's not that simple.
There is a JavaScript that helps us to achieve something different from traditional web application.
So let's go to our root component. So I'm going to do Control Command and then app.razor and hit enter. So we're looking at this root component, and you can see that we have this blazor.web.js. This JavaScript file is responsible to help us to solve this problem.
So one of the features that can help us with this problem is called stream rendering. So I'm going to change this back and add the stream rendering back again. And now if I change this to 2 seconds again and run the application, and now let's observe what's going to happen now. All right, so I'm going to home and go back to weather. And now you can see I have this loading thing going on. And then once the delay finishes, the part that is missing is kind of patched to the page. So from the user perspective, it's a better user experience. It's not like I'm waiting and waiting for the whole page, right? I already see that I moved to the weather page, right? It's just that the data needs time. So which is to the user, it's better user experience, it's more reasonable, and that is all resolved by this single attribute here. Right. Of course, something else going on here is trying to tell whether the forecast data is loaded or not. If it's loaded, then it's going to display the HTML table. Otherwise, it's just going to display the word loading.
If you're using Blazor static server-side rendering
to render some more or less static page, but in that static page, you have some area that needs some long-running process to load data and display, right? That part is not static, then you can use stream rendering to help you improve end user experience.
In this video, let's talk about static assets fingerprinting, which is a feature introduced in .NET 10. So let's go into Visual Studio. Let's actually go to the root component. Again, I'm going to do Control comma and then go to app.razor, hit enter. So you can see that for all of these linkings to these static assets, right, the style sheets, the JavaScript, we have this assets. This is like a implicit Razor expression. Right, so this implicit Razor expression is added here in order to add a hash within the referencing of the JavaScript. So let's actually run the application and let's see what the result is. All right, if I use F12 to bring up the developer tool, now you can see for all of the assets, right, the style sheets here, it's not bootstrap.min.css. They add something here, right? This is like a hash string. Now, this hash here is generated based on the file content. .NET is going to detect whether the content has changed or not. Once it's changed, it's going to regenerate this hash. So for example, if I go over here, right, go to the www root folder where the static assets sit. So I'm going to go inside Bootstrap. Maybe not using the Bootstrap. Maybe let's use the app.css, right? Because that's ours. So let's go to app.cs. And before I do any change over here, let's go to the lab folder. Let's just open up the folder. And it's showing up right here, actually, lab folder. Okay. And you can see the modification time is October 10th, 4:39 p.m. If I come over here and make a change, right, and then I save it, and then I change it back, and I save it. Now, if we look at this timestamp, you can see it changed to today's date, which is October 17th, 12:48 p.m. Now, if I run this application, let's actually close off this. Before we do that, let's pay attention to what we have over here. I'm going to take a screenshot. Okay, I'm going to take the screenshot and I'm going to bring up the Paint app and paste the screenshot right here so we can remember. And then I'm going to close off the application and even close off. Well, let's keep this so that we can come back and compare that if we still have it. Okay, so this is the previous one. We still have the hash, the previous hash. And now let's bring up the developer tool here. And if you look at this, I don't know whether I can make it bigger. Obviously I can. I can make this side bigger, but this side, it's KHY4L and ends with WU. So the previous one, the same thing, KHY4L ends with WU. When you look at the screenshot, it is the same thing over here. Look at this, KHY4L ends with WU, right? Because even though the file timestamp changed, the content inside here didn't actually change. So imagine if I go back over here and then I change something here, let's say this, instead of BB7, I'm going to change to BB6, and then I save it. So now the content of the app.css file has changed. If I close off the application and run it again, okay, now let me bring up the developer tool again. And if you look at app.css, it's completely new, right? This hash is completely different from before. If you look at before, it's KHY, whereas here it's 1GV. Now you know how the hash is generated based on the static assets fingerprinting, which is introduced in .NET 10. Now we need to talk about why in .NET 10 this feature is introduced. Well, if you have worked with web applications, you know that the browser tend to cache these static assets, whether it's an image or it's a CSS file or a JavaScript file, it tends to cache them. And even when you have an update for, let's say, a JavaScript file or image, the browser is going to just look at it and consider the new one is the same as the old one that is in the cache of the browser. So it decides to load the old version. And if it's image, that's not a big problem. But what if it's a JavaScript that contains a very important functionality? Therefore, the static assets fingerprinting is introduced to solve this exact problem, where it takes the content of the file and generate a hash based on the content. And then the hash is actually going to be part of the file name. Therefore, browser will treat it as a new file and will absolutely load that file into the browser. But if the static assets content is the same, then the fingerprinting hash will be exactly the same as before, even when the modified time has changed. For example, in app.css, I just roll it back from 6 back to 7. Right now, if I close this off and run it again, you're gonna see the same hash generated. So let's bring up the developer tool again and look at this app.css. We have KHY 4L and then ends with W. This is the same as before, KHY 4L W, and the same as this screenshot shows. So you can see this is definitely based on the content to resolve this specific static assets caching problem. Okay, that's everything I want to cover in this video. I'll see you in the next one.
This is a new section of this course, and this section is all about adding server interactivity to our application. But first of all, what is interactivity? To answer that question, we need to answer another question first, which is what is not interactive? In a traditional web application, a user works with the browser, and whenever the user requests any resource from the backend server, the browser sends a HTTP request to the web server, and the web server processes that request, and then come back with a response. Then the whole page will be reloaded. So therefore, within a certain amount of time, right, maybe less than a second, maybe 2 seconds, maybe 5 seconds, even more sometimes, right, the page gets reloaded. And during that period of time, you may feel like you lost connection for a moment, right, because the whole page gets wiped out and then comes back again. So depending on different conditions, like the connection speed, like the server's processing capability, that process may last longer or shorter. Anyway, the experience of the user is the browser is doing something and the process hangs there. So its experience is not smooth. Right? It's not like the user is dealing with a Windows application and the user doesn't see the screen refreshes. This is not interactive. But it's also a little bit confusing that the user is interacting with the browser, so there is already an interactivity between the user and the browser. When Microsoft mentions interactivity in Blazor technology, Microsoft is not actually referring to the interaction between the user and the browser. Microsoft is basically saying that this full page reload is not smooth. Therefore, it's not interactive. An interactive application should work like a Windows application. For example, this browser is a Windows application. You don't see this whole thing wiped out and come back again, right? It doesn't refresh this whole screen all the time. Whereas in traditional web application, the whole page gets refreshed. So that's not interactive. In order to solve this full page reload problem, naturally, we're thinking about instead of reloading the whole page, we just need to update the part that needs to be updated, right? So that's a partial page update, or it's also called partial page rendering. And that partial page rendering is what we call interactive. So once you achieve partial page rendering, you're going to call this application an interactive application because it looks much smoother. Right? It doesn't re-render the whole thing anymore. So traditionally, when we try to achieve partial page rendering, we use JavaScript. Instead of working like this, it's working slightly differently. So let's copy and paste this diagram. And then what is happening here is that the user interactive with something that is called DOM, Document Object Model, which is part of HTML page. The user interact with DOM. Well, the user does interact with DOM in the traditional web application anyways, but here it makes a lot of sense to point this out, that the user interact with the DOM, and then the developer has to write JavaScript in order to capture the interaction between the user and the DOM. Once that interaction is captured, the JavaScript will send request to the backend server. So typically the backend server has a web API, and the JavaScript just calls the remote web API and get the data back from the server, right? So data is back from the server. Usually it's in JSON format. And then JavaScript receives the data and maybe process data a little bit and use that data to patch the DOM. Once the DOM is patched, the page is partially re-rendered. And now the user sees the new information, which is the information that the user expects to see. As you can see, traditionally, when we want to add interactivity to a traditional web application, a developer has to write JavaScript. But in Blazor, Microsoft has different ways to achieve interactivity. Some of them involve JavaScript, but Microsoft provides the JavaScript file. Now the developer doesn't have to write JavaScript anymore. And some of the solutions of achieving interactivity is to use WebAssembly, which we're going to cover in detail in future videos. But in this video, I just want you to understand what is not interactivity and what is interactivity. Right? So to summarize, in traditional web application, the page has to reload every single time, and that is not interactive. And when you can partially render and patch the DOM, whether you use JavaScript or WebAssembly or something else, that is called interactive, right? And that is interactivity. So starting from the next video, we're going to talk about different ways to make interactivity possible in Blazor. If you have any questions, please let me know. If not, I will see you in the next one. In this video, we're going to learn about enhanced navigation. Enhanced navigation is actually the first step toward making application interactive, and it is actually enabled by default. That's why when we use static server-side rendering, which is supposed to be working in the same way as a traditional web application, we're not actually seeing page refresh every single time. I don't know whether you paid attention or not, but it's not actually reloading the page every single time. So let's go into Visual Studio and run the application that we have so far. Okay, if I switch between these menu items, pay attention to the browser, and as you can see, the page is not actually completely re-rendered. Especially the left-hand sidebar stays there without being re-rendered. So the only possibility of this is that the whole page is actually partially rendered. And that is actually true. When you create a Blazor web application through the Blazor web app template, enhanced navigation is enabled. And that is actually enabled by this JavaScript file in the root component over here, which is this one that we actually talked about in the previous lessons. Actually, let's delete this JavaScript file reference for now and see what happens. So let's rerun the application without the blazor.web.js file and see what happens. Going back to the application, now if you pay attention to the tab, and if I switch between this, now you can see that it refreshes the whole page, and you can actually feel the refresh. And if we bring up developer tool and go to network, now if I go to weather, and you can see that here is the request that sends to the /weather page, and the type is document. The initiator is other, which means it initiated by some other page. If I go to manage server, now the whole page refreshed, And again, this is the request, and the initiator is other. The type is document. Document means the whole page.
If we put the blazor.web.js JavaScript file back and try to run it again.
Now, if I switch between this, and if you pay attention to the top left corner, this favorite icon here, there is no refresh, right? There's no spinners going on. Everything on the page looks much smoother. Now, if I clean up this network tab here and now I switch back to home, as you can see that it goes to localhost, which is home, right? But you can see the type is fetch, it's not document anymore. And the initiator is blazor.web.js. If I clean up this again and switch to weather, same thing. Type is fetch, initiator is blazor.web.js. Clean up this again, go to manage servers, I get the same thing. Now, if I go over here and click on edit server, now one is the request and it's also fetch, and initiator is also the same JS file. And another thing I want to show you is if we go to elements and we open up this and open up again, open up article. So this thing within the article is the actual page component. And if I switch between these items here, if I go over here, you see that only this portion is updated, not everything else. Now I switch to home, only this portion is updated, not everything else. This is indeed a partial page reload. Now, how does this work? Let's go back to a diagram and I'll show you how this works.
Our static server-side rendering
with enhanced navigation enabled, which is enabled by default. Whenever the user interact with the DOM, there's supposed to be HTTP request sent to the web server, just like in the traditional application. It's supposed to do this, but it's actually intercepted by our blazor.web.js file. And then the blazor.web.js file internally uses fetch API to contact the web server. And it sends the HTTP request to the server, the HTTP response comes back, and then the blazor.web.js file handles parse the HTTP response and get the information that it needs, and then it smartly patches the DOM, which means that the DOM is partially rendered. Now, with this model, we actually achieved interactivity, depending on the definition that we provided in the previous lesson. Partially rendered web application is supposed to be interactive web application. So therefore,
static server-side rendering
by default, when enhanced navigation is enabled, is actually an interactive application. Even though we didn't add server interactivity, we didn't add WebAssembly interactivity,
Blazor with static server-side rendering
is an interactive application because our blazor.web.js file. This file is written by Microsoft. When you work with Blazor SSR, you don't need to write any JavaScript. This application is already an interactive web application. In this video, let's learn about enhanced form handling. As you can see from the previous video, with the help of enhanced navigation,
even static server-side rendering
can help developers to create interactive web applications. However, with enhanced navigation, the only thing the user can do is to navigate from page to page and load static pages. So what if the user wants to do something dynamic? What I mean is, for example, if we come to our application here, let's close this. Let's go to Manage Services. For example, if I click on Montreal, I want to list all of the servers that belong to Montreal. If I click on Ottawa, I want to list all of the servers that are in Ottawa. So that means the user is doing something on the page, provide some kind of information by either clicking or using keyboard. Other part of the page needs to be updated. So that's what I mean by dynamic. So with enhanced navigation, all we are doing is just navigating from page to page. Even just clicking on this edit takes us to another page. Click on this close, take us back to the previous page. So there's no updates within the same page. But with the help of enhanced form handling,
even static server-side rendering
can help us to make a page dynamic. Right? We don't have to make anything fancy. We don't have to have signal channel. We don't have to have WebAssembly. We can just use the edit form component to help us to achieve dynamic content and partial page update. And in this video, let's see how that's achieved.
Let's jump into Visual Studio and let's go to server component.
And here, what I want to do is to first of all display the server component on the servers page. So let's go to servers page, and let's for now just put the server component right here in the paragraph. So server component, we have used this server component before to demonstrate reusable component. And now let's put it back and try to use it to demonstrate enhanced form handling. So for now, let's put it here and rerun the application, and let's see what is being rendered. All right, let's go to manage servers page, and we can see that it says server 1 is in Toronto, that is offline. So this part is from the server component. Now, what I want to do is to add a button here to toggle the status. So when I click on the button, the offline needs to change to online. And when I click on it again, the online will change back to offline. So basically, the status of the server is toggled by clicking on the button. So for that, let's go to our server component, and we need to add a button here. First, I want to add a space like this, and then I want to give it a button. So this button is going to have to do something for us.
And in static server-side rendering,
the only way you can do that is with the submit button. That means somehow we need to make this a form. Okay, so let's finish composing the button here. So btn primary, and let's just call it turn on or off. So in order for the submit button to submit anything back to the server to handle, we need to provide a form, and it has to be the added form, not just the normal form. Okay, we're going to wrap all of the HTML inside the edit form. Here, for edit form, we need to provide a model. Otherwise, it's not going to work. And the second thing is we need a form name. Okay, so I'm going to call it server component form. Now, because I need the form, so I just need to add something to make sure the server is not now. And this doesn't seem to be useful because we're initializing this right here, but you will see why I have to do this in a moment. So I put it over here. Now, when the user click on the submit button, the information about the server will need to come back to a variable here. And for that, we have learned that we need to use the supply parameter from form attribute. And for that to make sense, this has to be changed to a property here. Now, let's actually comment out this for now. And I'm going to give it a question mark here to make this nullable. And now I can apply the attribute. All right. Once this attribute is applied, this is considered as a parameter. And therefore, our onParameter set is going to be triggered. So we're going to have to override this event handler here, onParameter set, which you learned this before. This is going to be the place where we initialize the server object. So if the server is null, we are going to initialize it, which is basically this part of the code. So let's copy this over here, and now we can remove this. Okay, so basically this line means that if server is null, then we are going to initialize with server 1 in Toronto. Now the form needs to be submitted and needs to be handled by a event handler. We learned that before, so we can say onSubmit, and who's going to handle that event? It's going to be change server status. You can call it anything. Right? This function or method is not implemented yet, but we're going to implement it right now. So here we're going to say if server is not null, then we are going to change server is online to the opposite of that. So this is going to toggle the is online status. All right. So If we do it this way, you are going to see that the server is always going to be null when it comes to here. So this is always going to be run. That's because inside the edit form, there's no input field. So therefore, nothing is going to be submitted back. So therefore, when the supply on parameter from form happens, nothing is going to be supplied. Therefore, the server object is only going to stay null. When a user clicks on the submit button, in order for the forms to be actually submitting the server information, we actually have to put all of the fields for the server inside the form, right? So I have done that. So I'm going to just copy and paste the code over here. And then I'm going to explain that a little bit. Here, you can see that we have input number, which contains server ID. We have input text, contains server name and city. We have checkbox containing server is online status. And you can see that all of these are hidden fields. Hidden fields still work. And when the user clicks on the submit button, the information of the server object will be submitted back. And when that submit back to the server, when I say submit back to the server, I don't mean the server object. I mean the backend of the server. So when it comes to the backend, the supply parameter from form will work, and the server object is going to be populated by these values. And that's what we want. After that happens, the change server status will be triggered, and the server is online status will be toggled. That's what's happening. And once the server is online status is toggled, the view is going to be updated. And as you can see, the style dominates the color change. So therefore, we are going to have the color change. All right, so let's rerun the application and see what is going to happen. All right, the application is updated. Now we can see it says server 1 is in Toronto, that is online. And if I click on turn on or off, you can see that it actually changed to offline now. And the color changed to red. And if you pay attention to this, let's close this first tab. Just pay attention to this icon here. I click on it. You can see that it's actually refreshed. The whole page gets refreshed. So what if I do it this way? Here, right? So I make this browser smaller. And then if I scroll down to this line over here, I click on it. You see, the whole page reloaded. And therefore we lost our scrolling position. But if we scroll down, you can see the status actually changed to offline. Let's try this again. Now it's offline. I click on the button, the page gets refreshed, and it's changed to online. So our logic works. The only thing is that the whole page gets refreshed. Another way to demonstrate this is that let's go to network, and then let's click on turn on or off. And you can see that the server's page is a document and triggered by other. That means the whole page gets refreshed. If we watch this part as well, let's open it up, scroll down, click on it. You see this whole thing gets refreshed, and therefore the elements collapsed. That means that we made this page dynamic. Okay? The user provide information and the backend server handle the information. The problem is now that the page is not partially rendered, it's completely re-rendered. And that's not interactive. We want the page to be interactive. And that's where enhanced form handling comes to rescue. We are using edit form to try to achieve dynamic. However, that dynamic is dynamic, but the page is not partially rendered. Enhanced form handling will make the re-render partial. And it is actually very, very simple. We just need to add an attribute here. So enhance equals true. This is also called parameter of the component. We set it to true. When we do that, let's rerun the application. And let's go back over here. We scroll down and click on turn on or off. Now you see we don't lose our position, but the page is actually updated. You change to offline. Click on it again, change to online. Click it again, change to offline. And if we watch here, right? So let's open up, go to main, go to article, and we see our form here. Click on the button. You see, the page is not reloaded and the information in it is updated, right? So page is partially reloaded. And now let's go to the network tab and let's try to click on the turn on off button here. And as you can see, every time I click on it, it goes to the server's page, and it is a fetch type. And initiator is also the blazor.web.js. So you can see that the enhanced navigation and the enhanced form handling is relying on the blazor.web.js. Therefore, you can see that enhanced form handling is using the same technology, which is all relying on the blazor.web.js. Let's go back to here. The enhanced form handling is also having the same structure here, right? The user interact with the DOM. And then when the form is submitted, there's supposed to be the post request goes to the server, but it's actually intercepted by blazor.web.js file. And then the JavaScript internally sends a fetch API and get information that is needed and then patches the DOM. And that's why you're seeing this initiator, blazor.web.js, and the type is fetch. And it's so simple. You just need to remember to use the enhance to set the enhance to true on the edit form.
That means with static server-side rendering, you already have all of the tools
to achieve interactivity. You can make the page interactive, you can make the page dynamic, and you don't have to do a lot of extra things, which is going to help us to partially render the page when we navigate from page to page. And with the help of enhanced form handling, we are going to be able to partially update the page when we need to make dynamic changes on the page. With these two features, we can use static server-side rendering to achieve almost everything we want to achieve. However, there's something even better,
which is called interactive server-side rendering.
And I'm going to cover that from the next video. That's the main thing we're going to cover in this course. What is server interactivity?
Or interactive server-side rendering?
So in the previous two videos, we have talked about enhanced navigation and enhanced form handling. And we were able to see that by using those two features, we are able to achieve interactivity. Our applications are actually interactive. But when Microsoft referred to server interactivity
or interactive SSR,
they actually mean something similar, but also different. So if we go back to enhanced navigation here, or even just go back to this diagram, we can see that the way to achieve interactivity is to use a JavaScript and work with the DOM. And then the JavaScript will work with the backend server. With enhanced navigation, we're using the blazor.web.js file to work with the server. So it's all about the JS file. The actual server interactivity is also relying on the blazor.web.js file, but this time the request and response is different. So let's copy this diagram and see how
the interactive server-side rendering works here.
So we have the same diagram, but here is different. Instead of using the blazor.web.js to send fetch API requests to the web server, server interactivity is using the blazor.web.js file to set up a WebSocket channel, and that is called a signal channel. So let's use this bar here to represent the channel. And let's change the color to slightly like silverish. So what happens is that the first time when the page is rendered, there has to be a request and response going on here. So a HTTP request goes to the server, and then HTTP response comes back, and that renders the DOM. That also makes the JavaScript file available inside the browser. And then immediately a WebSocket channel, which is the signal channel, is established between the browser and the server. When this signal channel is established on the web server here, let's remove the letters here. Inside the server here, an in-memory representation of this page. Let's use this rectangle to represent that. So a memory representation of this page is held inside the memory, right? And that is actually connected with the signal channel. So therefore, when the user interact with the DOM and when the Blazor.web.js captures that interaction, messages, in this case is like actually binary messages, will be sent inside the signal channel, right? Like this. And here, when the in-memory representation of the page receives that message, it will interpret it and it will process that. And when the process is finished, binary message will come back through the channel and captured by the Blazor.web.js file. Now, this JS file will interpret the binary message and then it will patch the DOM. So the difference between this and this is not only in how this communication is done, but also the backend is completely different. Right here, this is still a request and response model. The web server doesn't hold anything in memory. Every time a response comes, it will load objects into the memory and do the processing, and then request comes back and everything will go out of memory. Right? Another request comes in, the objects will be created again, and then response goes back, the objects will be disposed again. Here, everything is held in memory. A signal channel is held consistently between the browser and the server, specifically the component or the component tree. And the communication method is using the signal channel, and what is going on between the channel are actually binary messages. So the communication is pretty fast, and the messages are made in a way that they are very efficient, very minimal, so therefore the performance is not bad. Now, to make this part more clear and see at the backend how this all works together, I have to mention another concept, which is something called render tree. So in the DOM, we have the concept of render tree. All of the HTML elements are grouped together in a tree format. We have elements, and then one element may have a sub-element, so it looks like a tree. In the backend, when the in-memory representation of this page is held inside the memory, there is also a render tree that is held in the memory. In fact, there are two render trees. Let me use this diagram to represent the render tree. Let's say I use this component to represent this component. And this component actually has two subcomponents, or in other words, two child components. And this is a tree. So this render tree, it needs to be rendered inside the DOM eventually. But currently it's held in the memory. And this is what we call the previous render tree. And this previous tree is held in the memory. So after the user interact with the DOM, and then the Blazor.web.js send a message to the component here, the component inside the memory process the request, and then it will generate another copy of the tree, which is a new copy. And the new copy of the render tree represents new information. So this is called new tree. Right? In this new tree, perhaps some information in the child components are updated, or perhaps another component is loaded like this. Now, Blazor is going to compare between these two render trees, and it will see the difference. In this case, obviously, there's an additional component added to the tree. So therefore, it's going to pack this component into binary message, and it will send this information to the Blazor.web.js in the browser. And the JavaScript file here, understand that there's only this additional component is added, then it will patch the DOM with this additional component. So what this is called render tree difference. And that render tree difference is understood by the Blazor.web.js, and the JS file updates the DOM. The user sees the difference now. So that's the whole process. That's how Blazor server interactivity works. Okay, just to summarize, when the page is just loaded, it's based on HTTP request and response model. And then the DOM gets all of the information, including the JS file. Immediately, the signal channel is established. And then when the user interacts with the DOM, the JS file send binary messages. The component inside the memory is going to capture that message, process that message, create, add or remove information to the render tree, and then it's going to compare between the previous render tree and the new render tree. Is going to see the difference. It's going to get the div between the render tree, and then it's going to only send that div, not the whole tree, back to the browser. Now the Blazor.web.js captured that message and understand that message, then it's going to patch the DOM. So therefore, the page is partially re-rendered, and that achieves the server interactivity. That's everything I want to cover in this video.
And in the next video, we're going to see how to enable interactive server-side rendering and how to use it.
In this video, we're going to learn how to enable server interactivity in order to make a component interactive. We are actually going to work on that in Visual Studio. So in order to demonstrate that, we are going to make this server component, which is this one, interactive. Well, we already made it interactive with enhanced form handling. But this time, we're going to remove the enhanced form handling. We're going to use server interactivity. So let's go ahead and do that. Let's remove edit form along with all of these views. We don't need that anymore. And let's remove the clothing tag here. Now we can recover this, and we're going to initialize the server variable here where we define it. And then I'm going to delete this onParameter set, and we're going to delete this event handler as well. Now this button has to be now changed to button, and we can just handle the click event. So here we are going to say I want to change status, and now we are going to declare this change status function inside our code block here. And inside here we can simply just say this dot server dot is online equals the opposite of it. So if this is true, then the result will be false. If this is false, the result is true. We can use something like if server is not now, then we are going to set it. All right, let's try to run this application, and you will see that the breakpoint here is not going to be hit. Right? Let's set a breakpoint here, run the application in debug mode, and now let's go to manage servers. We see this server is in Toronto, that is offline, and click on it. Absolutely nothing is happening. Go to network tab here and again click on this. You can see nothing is happening. That's because we haven't actually enabled server interactivity yet. So let's go back and stop debugging. And then let's go to Solution Explorer here.
Go to program.cs. This is where we can enable interactive server-side rendering. So first thing here, at the last middleware here, we can connect that with, let's see, add interactive server render mode. So this enables the interactive server-side rendering for this map Blazor component middleware. And whatever that is required over here, like whatever the services are that are required for this particular functionality, should be added at the top here. So we connect this add Blazor component with dot add interactive server components. This adds the dependencies that this requires. Once these two lines are added, we can rerun the application. We're going to run it in debug mode.
Now, if I go to manage servers and click on turn on and off, and you can see it still doesn't work. So there is another thing that needs to be added.
Let's stop debugging and go to servers.razor over here,
where the server component is added to the managed services page component. Here we need to specify the render mode. So render mode equals interactive server. And that's it. That will enable server interactivity. Okay, so there are two things you need to do. One is in the program.cs, you need to add these two lines. Secondly, you need to specify the render mode. And there are different places we can specify the render mode. I'm going to talk about it a little bit later. Right now, let's just run this application and see how it works. But before we do that, remember to delete this paragraph element. It's going to actually cause some issues with the server-side rendering, turn it on. So let's remove that because it's not necessary anyways. All right, let's run the application now. And we have a breakpoint set up here. So let's run the application now and see what's going to happen. All right, our application is running. Let's go to Manage Servers. And we see our component here. Server is in Toronto. That is offline. Let's click on the button. And you can see that the breakpoint is triggered just because we added an event handler here. Right? There's no forms. There's no HTTP post request. It just works. And let's remove the breakpoint and continue. Now you can see it's turned back on, and click on it. We'll make it go off, on, off, works very well. And now let's examine the network tab here. So F12, bring up the developer tool and go to network here. And scroll down and click on turn on. And you can see there's no request coming on, right? There's nothing going on here. That's because we are not actually watching the SignalR channel. So in order to see the SignalR channel, let's actually refresh this whole page. Right? So this first time when the page is refreshed, what is happening is exactly in the diagram that I showed you. Right? First time, there is a HTTP request and comes back with a response. That renders the page. And that also renders this blazor.web.js file. So we can see that it goes to the server's page as a document, and then the blazor.js file is downloaded to the browser. And we have SignalR channel that is established. In order to make it clearer, let's make it separate. So this is the one that we were looking at. This is the actual SignalR channel. It's established between the browser and this component inside the memory on the backend. If I make this appear on the left-hand side and make this appear on the right-hand side, and now if I click on the button, you can see the message is growing. See, 2 message goes to the server and 2 message come back. Each time I click on it, the messages are being sent back and forth. And you can see the length of the message, a few hundred bytes. So pretty tiny. And that's the diff between the render trees that I mentioned in the previous video. So in order to review how Blazor server interactivity works, I'm going to take this opportunity to go through what's happening in that diagram again. So when I click on the turn on and off button, this event is captured by the blazor.web.js file. And a message is sent to the memory representation of this component in the backend, right, on the server. That component receives that little message, a few hundred bytes, and then it executes this function. When the function is executed, the state variable here, which is online, is changed. And when that is changed, the HTML here is re-rendered. And that render tree is compared with the previous render tree, and then we'll see the difference, right? You will see that the word changed, the color changed. And that information is packaged together as a binary message sent back through the SignalR channel. Now, the JavaScript on the front end received that message and patched the DOM. So it changed the color right here, changed the word offline to online. And if I click on it, this is happening over and over and over again through the SignalR channel. In this video, we're going to learn about interactive location. I'm sure you have seen this term on the Visual Studio template, but what does it actually refer to? So let's come over here, and we made this component in the previous video. In the previous video, we made this server component interactive.
What we did was in the program.cs file, we added this line and this line, but that's not enough.
Inside the servers.razor, where we use the server component, we specify this render mode and we set it to interactive server. So this is called interactivity location because there are different locations you can set the render mode. Therefore, this location is called interactivity location. Generally speaking, there are two different categories of interactivity locations. The first type of location is set on the page or set on the component. For example, for this location where you set the render mode on a component, either you set it right here where you use the component, or you set it in its parent component, or you set it inside the component. It's all going to work. And you notice that all these three different locations belong to the first category where you set the render mode either on a reusable component or on a page component. So let me demonstrate that. That's the first category. So first of all, I want to remove this just to make sure that removing the render mode actually takes away any server interactivity. Let's go over here, and then when I click on this, you see nothing is happening. So the first category of specifying the location of interactivity is at the place where you use the component. But it doesn't have to be on the component. It can be on its parent component. For example, I can specify the render mode here. And when I specify it right here in the page component, then the page component itself and all of the subcomponents, this entire component tree is using server interactivity. So now let's go over here and I click on this. You see it's working. It's working very well. So you can set it in the parent component, no matter whether it's page component or reusable component, or you can set it at a place where you use it right here. Or you can specify it inside the reusable component. So you can do something like this. And when you do it like this particular component and all of its subcomponent, right? This entire component tree starting from this particular component will be using server interactivity. So let's go over here. This is still going to work. See? So this is the first type of interactivity location. In this type of interactivity location, you specify the render mode on the component, either the component itself or inside the component or in its parent component, depending on your need. That's the first type. So the first type of location is at the page or component level. Now, the second type of location is at the global level. So if I roll back all of the code, and then let's go over to servers component here, and let's remove this render mode. So now there's no render mode specified, so this component is not going to work. But if you go to the root component, where we have the router component over here, here you can specify the render mode. If you still remember, this router component encompasses the entire application. So every part of the application will be affected if you set the render mode here. So if you set the render mode to be interactive server, then the entire application is going to use the interactive SSR as the render mode. If you set it as interactive WebAssembly, then the entire application's render mode is going to be interactive WebAssembly. So in terms of interactivity location, we have these two types of locations. Here is the global location, right? Because it affects the entire application. The other one that we saw that we applied to on the component level or page level, that's the page component level interactivity location. Now let's change this back to interactive server. Once you do it here, the component here is going to work. See, it's working. The server interactivity is going to work under the entire application, no matter which page component or reusable component you write code, you can use server interactivity. All right, those are the two types of locations. But what is recommended by Microsoft is to use what we used before. So instead of using the global level location, we're going to roll back the code here. And let's go to servers here. Actually, let's just roll back this as well. So this is what recommended by Microsoft. because we know that out of all these applications, every page component, only this component here is using server interactivity. Therefore, I specify the render mode to be interactive server right on the component. And you may ask, can I just go inside here and specify it on top of this component? That way, I'm just specifying that this component is using server interactivity. That's not actually recommended by Microsoft, because later when you learn about WebAssembly interactivity, you will know that you can actually enable WebAssembly interactivity on this very component. So if you specify your render mode inside this component, you kind of locks your component interactivity mode. Therefore, it's not recommended to specify the interactivity inside a component. It's recommended to do that outside the component where you use the component. So you specify it as an attribute. You just need to remember there are two types of interactive location. One is on the component or on the page itself. The other one is global location. In this video, let's quickly cover the server interactivity inside the Visual Studio template. Because when we create this project, we created as Blazor SSR. So we didn't specify interactivity when we used the Visual Studio template. So let's clarify that.
Let's jump into Visual Studio and let's actually close this solution. And I'm going to create a new project by clicking on this button. And we're going to still select the Blazor web application template. Let's click on next. And you don't actually have to follow this, because what I'm trying to talk about in this video is very simple. You don't have to follow. Let's click on next button. Now let's select the latest framework and let's take a look at this interactive render mode here, right? In the past, we started with none. And when we select none, you can see the location, the interactivity location drop-down list is hidden. Now, if I switch back to server, now you can see the interactive location is displayed right here. All right. So let's open up, and you can see we have two type of locations, just like what we mentioned in the previous video. Let's start with the per page per component location. Okay, and let's keep everything else as default and click on the create button. Now we are going to see a default application straight out of the template. And if we look at the program.cs file, you can see that we do have these two lines added, right? Add interactive server render mode and add interactive server components here. Right? One is to add the functionality, the other one is to add the dependency. But if we go to the components and go to the root component over here, you can see on the router component, we don't have the render mode specified here. And if we open up the pages folder and we go to, let's say we go to home, you can see we don't have the render mode specified on the home page. We don't have it specified on the weather page, because these two are using static server-side rendering. The only thing, the only component that is interactive is the counter component, right? The counter page component. And this is the place where we specify the render mode. Because this is a page component, therefore, this is the only place we can specify the render mode, which is directly on the page component. So you can see that in this Visual Studio template, that in this option, we chose to use interactive server-side rendering, but for the location we chose per page, per component, in this case, this is following exactly what Microsoft recommended. Only apply the render mode, right? The interactive render mode on the component that's supposed to be interactive. You don't have to use a user to cover the entire application, because most likely you will have some static pages. For example, the home page, the not found page, the error page, even the weather. You don't need it to be interactive with the user. You can just use static server-side rendering. Just specify the interactive render mode on the component or on the page that requires interactivity. Okay, so this is the per page, per component interactive server rendering. Now let's close the application again and try to create another one. We're going to use the same template. We're going to click on next, and I'm going to use the latest framework. And now, if we still select server, and we're going to use global, now click on create and see what it looks like, right? Let's go to program.cs. Program.cs is exactly the same as before. We have this line and this line. So what is different here is that once you go to the components and go to the root component, which is the app component here, you can see that the render mode is specified directly on the router component, which makes the entire application interactive. Therefore, if you open up the pages folder and go to counter, you can see we don't have the render mode specified on the counter component, which is supposed to be interactive, because in this case, the entire application is already set to use interactive server-side rendering. In the previous video, we talked about creating an application with interactive server-side render mode globally. So if we look at this app.razor, which is our root component, and then the render mode is specified on the router. So this makes the entire application, actually this head outlet as well, we make both of them interactive, then the entire application is using this interactive render mode that is specified here. But what if you know that most of the pages in your application should use interactive render mode, whereas certain pages you want to use static server-side rendering? Right? What if that's the case? Then Blazor actually has an attribute that supports that. So this is the application that we already made it interactive with server-side interactivity globally. Let's say that certain page, for example, this home page, it is static, and for a strong reason, maybe you just want some functionality from static server-side rendering that you think that is really good for this page. Let's just take the home page, for example. Right. In this case, what you can do is that you can exclude the page from using interactive routing. So what you need to do is use the attribute. You can say exclude from interactive routing, just like this. Right. Once you do that, the entire page component will not be using interactive routing. It's going to use static server-side rendering. But just by specifying this attribute is not enough, because globally, we're still using interactive server. Blazor cannot just change the routing based on your attribute. So what you need to do is to do a little bit more on this root component. You can go to Google and then you search exclude from interactive routing. And there is this ASP.NET Core Blazor render modes. Go over here, and then if you just search exclude from interactive routing over here, you can read this paragraph, right? Read this section, and you can see exactly how it works. But what I want to highlight here is that you can see the render mode is set dynamically for both head outlet and the router component. So this is the cascading parameter. We will talk about cascading parameter later, but right now, just considering this is a parameter that is fed to the component, to this page component by Blazor from outside. So you don't need to worry too much about what it actually means. So what we need to do is to copy this whole thing and go to our root component and paste it over here. Now, the render mode here, we want to change it to use the page render mode variable here. We'll come over here and change the interactive server to use the page render mode. So how this works is that for most of the component, it's going to detect that the page component accepts interactive routing, so it's going to use interactive server. Whereas for a particular component that you use the attribute to exclude the page component from the interactive routing, then it's going to see that from here, and it's going to use null here, which means the router component is not going to use interactive server rendering mode, and it's going to use the static server-side rendering mode, same as the head outlet, as if you didn't specify any render mode. So with this specified, then the component is going to, in this case, our home page component is going to use static server-side rendering. So let's actually run the application and observe what is happening here. Okay, so the application is running. If we bring up the developer tool and go to network tab over here, if we go to weather, you can see that I'm going to select, right now I'm looking at socket. If I go to all, and I'm going to navigate, actually, first of all, delete this. I'm going to navigate between the counter and weather. You can see that the page component is being switched over here, right? This is counter and this is weather and this is counter again. And there's no page HTTP request that is loaded right here, right? You cannot see that because everything goes through the SignalR channel. Now, if I go to home page, you can see everything is loaded here. And the type of this localhost, which is the home page URL, is document. What does this mean? This means that we didn't use the SignalR channel for loading the home page component. That's just because we have excluded the page component from using the interactive routing. So let's say I'm going to remove this and let's run it again. Now let's bring up developer tool again and make sure this is all. So I'm going to switch to counter, and you can see there's only 3 entries here. Let me actually clear this so that everything is clearer. So go back to home. You can see there's no HTTP request anymore. This is because this is interactive server-side rendering applied global. Okay, that's everything I want to talk about in this video.
In this video, let's talk about the 3 main aspects of interactive components. In one of the previous videos, we used this diagram to describe how server interactivity works. Just to reiterate, that when the user interacts with the DOM, that interaction is captured by our JavaScript, which is provided by Microsoft. And because there is a SignalR channel, which is a WebSocket channel that is established all the time, right? So messages are sent over, back and forth through the channel. And there is a in-memory representation of this particular page here on the server. So therefore, this is a stateful application. Once you use interactive component in Blazor, the application becomes a stateful application, at least for that component, right? The component is stateful. And it's different from unstateful component. If you still remember, I think I mentioned previously, right? A unstateful application is like the traditional application where every request, after the request and response round trip, the server disposes everything. Server doesn't remember the state of the application. And then another request comes, it reinitializes the application. None of the states are remembered. However, when we enable interactivity and use interactive component in Blazor application, the application becomes stateful. And for stateful components or for stateful application, there are 3 different main aspects in all type of stateful applications, including Windows or .NET MAUI or Angular, React, right? So those 3 different aspects are the view, the event, and the states. Now we have a user. This user interacted with the view, which is in our case the web page. The user doesn't care whether there's component or not. To him or her, it's just a page, and we call it the view. When the user interacts with the view, the action triggers some kind of events, and the events are handled. When we handle the events, as developers, we do something with the information that the user provided, because there's information in that user interaction with the view. So we do something. Maybe we calculate something. Maybe we retrieve some data from the database and then calculate something. Whatever we do, it changes the internal state variables. And that's what we call the states. The processing of the events or the handling of the events changes the state variables here. And when the state variable changes, that in turn modifies the view. So now you can see that this triangle is going on and on, right? So again, the user interacts with view, and that interaction creates some kind of event. When the events are handled, it changes the state variables. And when the state variables change, it updates the view. Now the user sees new information. he or she's expecting to see. So these are the three different aspects of any interactive component or any interactive applications. All single page applications are because they're all stateful. So let's go into Visual Studio and take a look at our server component, which we made it interactive a couple of videos ago. Here, when the user clicks on the button, this event is triggered. And that message is sent over to the in-memory representation of the component through the Signal channel. So there's no HTTP post and no HTTP request, right? So it just automatically triggers this event handler. Watch what we do inside here. We change the state variables. And what is a state variable? It's this state variable here, right here. So we change the status of the state variable. And when this changes, then it comes back and affect the HTML here. So this is the view, this is the event handling, and this is the state variable, right? User interacts with the view, triggers the event. When the event handled, the state variable changed. And when the state variable changes, the view is updated to reflect the new information. So these are the three different main aspects of our application. Right? Later, this applies to WebAssembly as well. So it's important to understand, because when you work with Blazor, you need to keep these three different aspects in mind. And in future videos, I'm going to refer back to these three different aspects over and over again. This kind of gives you a framework in your mind for your coding. Okay, that's everything I want to cover in this video, and I will see you in the next one. In this video, we're going to talk about event handling, passing data. So I'm going to pass data inside the event handler. Because so far, if we look at our code, so for example, in the server component, when we use server interactivity, we're just calling the method. Right? And this is a simple method. It doesn't have any parameters in it. So what we want to do is that when we click on a button or doing something else, we want to call a function that, and at the same time, pass some kind of parameters to the function. Right? Pass information to the function so that when the event handler function is triggered, it can take advantage of that information in the parameter. And for that purpose, what we want to do is we want to do something with these city buttons. So let's rerun the application. Go to the Manage Server screen here. We have created these city logos and buttons here, but these things are not doing anything yet. Okay, we want to make these buttons work so that we can load the servers that belong to other cities other than Toronto. Because currently we hard coding Toronto, all of the servers are under Toronto. We want to click, for example, click on Montreal, want to see all of the servers belong to Montreal. Click on Ottawa, I want to see all of the servers belong to Ottawa, so on and so forth. So let's go ahead and do that. Let's go to our Visual Studio here, and then let's go to our servers page component here. And these are our city buttons. And this is the view in those three different aspects. So now we want to handle the clicking interaction. To do that, I hope you still remember, we can just use the @ on click. And we're going to handle this event handling. And in order to pass information, we can create a function to handle the click event. So let's scroll down to the code block here. And I'm going to create a private method here or a private function here. I'm going to say select city, right? And I want the city name that is clicked on to be passed inside here. So I'm going to say city name. And somehow when I call that select city, I want to pass the city that we clicked on. So how do I do that? If I just do something like this, as you can see, there's red squiggly line, it means syntax error. So we hover the mouse over it, it says cannot convert from void to event callback. So it basically is saying that this is not supported. Then how do we pass data to a event handler? We can use the explicit reserved syntax. So we can do something like this. @ parenthesis, and within this parenthesis, we can use arrow function. And then within the arrow function's body, which is within the curly braces, we can trigger our actual event handler function. And then at the same time, we pass this city variable inside the function as the parameter, right? Because here the city is actually a string. So therefore, it can be accepted right here. Now we have our view, we have our event handling, and we have our event handler. What do we want to do inside our event handler? We want to change the state variables. And how do we change that state variable? First, we have to declare that state variable. So here I'm going to say selected city, and I'm going to actually initialize that to Toronto because that's what we do currently. And inside this, I'm going to actually say this dot selected city. So I'm accessing the state variable here, and I'm going to set it to city name, just like this. And now what I want to do is simply just display which city is selected, just for now. So in here, I'm going to use implicit razor expression, and I just put it here just to see the result. Okay, let's run the application again. In fact, this is not going to work. Because when I click on it, it's not changing. It's initialized to Toronto, that works, right? But when I click on it, it doesn't actually work. Why? Well, we have to ask ourselves. We enabled server interactivity already in program.cs. We see these two lines, but why still doesn't work? Well, we didn't specify the render mode. That's the interactive location. And because we're doing that inside the server's component, which is a page component, so we have to specify it right here. There's no other places other than this. One other place is that global location, which is inside the router. So I don't want to do that. So I'm going to just specify the render mode right in here. So I'm going to say interactive server. When I do this, I don't actually have to specify this render mode anymore, but I'm going to keep it here. Right? I'm going to just keep it here. It doesn't actually matter. So I'm going to rerun the application. And now if I click on Montreal, I see Montreal. Click on Ottawa, I see Ottawa. Click on Halifax, I see Halifax. So it's actually working. So now you see why I showed you these three different main aspects of a stateful application, right? So it kind of works as a guidance to guide us through the steps of working with Blazor application. We know this is the view, so this is important. We want to make change to the view when the user interacted with it. And then when the user interact with the view, we want to handle the events. Right now, we're passing information to the event handler. And if we go to the event handler, we're making changes to the state variable. And then when the state variable is changed, that result is reflected on the view itself. So inside the HTML. So that, again, shows the importance of the three different aspects. It works as a guidance. So every time you work within a stateful component, right, interactive component, just keep in mind that you have these three different aspects. All right, that's enough theory. So we want to do some real things here, right? When we select city, what do we want to do? We want to load all of the servers. So let's go to the selected city here. In fact, we are still going to do this. However, we are going to remove this. I don't want to see the currently selected cities. This is just for demonstration purpose. So other than just reset the selected city, what do we want to do? We want to reload this particular state variable, which is servers. So I'm going to say this dot servers equals servers repository dot get servers by city. And I'm going to say this dot selected city. Right, so this is changed inside event handler, and then this view is re-rendered. It's going to reflect the servers. Well, you may ask that last time when we worked with the edit form, we remove the initialization. Why we don't remove the initialization? Is this going to bother us? Is this going to reset the server's variable to Toronto every single time? Is this going to affect our event handler? No. Why? That's because we're using this model, right? We have an in-memory representation of the page, and that is held inside the server's memory. So it's keeping a state. It's not going to reinitialize it because this page is already initialized. It's remember its state. It doesn't work as a unstateful application anymore. So initialization only happens once. When you work with edit form
with static server-side rendering,
this whole page is actually reconstructed every single time. It's just that it uses the enhanced form handling. Therefore, you don't see the whole page reload. But at the back end, everything is reconstructed every single time. Here, everything is only constructed once. And then changes are made and the changes are re-rendered in the view. So therefore, we don't care about this. We can initialize this to Toronto. That's it. That works. However, here, when we change the servers, it's going to re-render the view and the user will see the re-render view. So let's give it a try. Rerun the application again, and let's go over here. Okay, just to reload this page, just make sure that we are looking at a refresh page. Okay, now if I go to Montreal, I see server 5, 6, 7. That's exciting. If I go to Ottawa, I see server 8 and 9, Calgary 10 and 11, Halifax 12, 13, 14, and 15. Go back to Toronto 1, 2, 3, 4. That's the beauty of interactive server. You see that it's actually simpler
than static server-side rendering.
Except that it's keeping this state, right? So later when the page grows very big and state management could become an issue. But for simple applications here, well, it's very straightforward. It's just like JavaScript. You have a button, you handle the event, and you do something in the handler and immediately you see changes on the screens like JavaScript. It's simple. But just keep in mind the 3 different aspects of stateful application and you will be good even in the future when the component becomes bigger. Just keep those in mind. Okay, that's everything I want to cover in this particular video. I will see you in the next one. This is the next assignment video where you want to highlight the current selected city. So in our current application, we have this city list here. So if you click on Toronto, it's showing Toronto's servers. Click on Montreal, it's showing Montreal's servers. Click on Ottawa, showing Ottawa's servers. But there's one thing that I really want to do is that I want to highlight this entire area for the current selected city. Right, currently Ottawa is selected, only the button is highlighted. I want this entire area to be highlighted so that it's very obvious which city is being monitored. So therefore, I would like you to work on this. You may find this assignment quite simple, but the purpose of this assignment is to help you keep in mind of those 3 different aspects of interactive component. So when you work on it, think about what is the view, what is the state, and what is the event handling, because it's entirely different from unstateful applications. As for how you want to highlight this area, it's entirely up to you. I'm going to use Bootstrap classes in the next video when I do it, but it's up to you how you want to highlight it. Okay, that's everything. All right, I'll see you in the next video where I'm going to show you my solution. In this video, let's work on this assignment to highlight the current selected city. And this is the servers component where we want to work on it. And we just want to be clear that these are the view, right? These HTML represent the view and the user interact with the city button here. And we are going to handle the event in the select city function here. We're reloading the servers, setting the current selected city. And by using this state variable, we can highlight the currently selected city. So I don't know how you want to highlight it, but I'm going to use Bootstrap class, and you can refer to Bootstrap documentation, and you're going to see that there is something that is called border primary, and that can be used on this div here. So I'm going to highlight this because currently it has a border. I can specifically say that I want to have a primary border. So for example, if I just put in this class, I'm going to get this. So every single one of them has a blue border. That's the primary border. So therefore, I'm going to use this state variable here. determine who's going to get the primary border, who's not going to get the primary border. Because the fact that this component is being held in the server's memory, therefore we can do that.
For static server-side rendering, it's going to be different.
It's going to work, but it's going to be different, right? You're going to post the whole thing back to the server in order for the server to get the state. Otherwise, you don't have a state, right? Because it's unstateful. Therefore, every time you want the server to do something, you have to let the server know by posting the state back to the server. So here we already have it because of the SignalR channel, because the in-memory version of the page. So we already have it. We can directly use it. And how do we use it? We can use explicit razor expression here. What we can do is we can remove this, and then we can either use the explicit razor expression for the entire class, or we can just add something here, right? So we can say if the selected city is equal to the city, then I'm going to provide, right, the primary border class. Otherwise, it's going to be empty, right? We're basically appending another string over here, and it is based on the current selected city and the current city in the loop, right? If they're equal, then we're using the primary border. So that way, we're only highlighting the city that is currently selected. All right, so let's rerun the application and see whether we got the result or not. Okay. Right now, Toronto is selected. If I click on Montreal, Montreal highlighted. That's beautiful. Calgary is highlighted. Click on Halifax. Halifax is highlighted. We have all of the servers for Halifax. For now, we don't need this component, so let's clean this up. Let's take the chance to clean it up. So delete this and rerun the application. I just want to see that page is clear, right? So everything looks good. Click on different cities, give me different servers. Click on add server, the add server functionality here. So let's say Halifax, I want to add server 16. I'm going to say server 16 in Halifax, and it's online. Click on save, and now I'll go to Halifax. I have server 16 here. So everything works beautifully, and that's all I want to cover in this video. I will see you in the next one. In this video, we're going to learn to update state variables with onChange event. We know that we have these three different aspects in any stateful applications or interactive components. Actually, we have talked about view when we talk about razor syntax, right? And we have covered a little bit about events in the previous video. Now we're moving on to talk about the states. And there are different ways to update the state variable. You have seen what we have done here to pass data to the event handler function. Now in this video, we're going to use the onChange event, which is kind of similar, so belong to the same category of passing data through the event handler. And then after that, we're going to learn about data binding. Now the scenario here is that below the city buttons and above the service areas, I want to have a search bar so that I can search the servers. And for that, let's work on the view first. I'm going to add another line break here, and then I'm going to have a div with the input group because I want to group the search bar with the search button together. And for the search bar, I want to use a input, and here type is text. And the bootstrap class is going to be just form control. I want to add a placeholder so that people can see the purpose of the search bar. It's going to be search servers. And now the key part here is to use the onChange event. So I'm going to just say @ onChange. And then the function that is going to handle the event is going to be called server filter changed. You can give it any name. Or, for example, you can say handle server filter change. Well, actually, let's use that name. And this is not defined. We're going to define it later. Here, I want to just add a button. And the class is going to be btn and btn dash outline secondary. Right? You can use any style. I just prefer this outline secondary. And then type is going to be button. And I can give it an ID and just call it button search. And now the caption of the button is just search. Now we need to implement the handle server filter change event handler here. So let's scroll down to the code block here and just create a function here. Handle server filter change. When we use this type of handling here, Blazor actually pass some kind of parameters into the function. It is called change event arguments. And now we can take advantage of this to reset the filter. So arguments dot value. So this contains, see, this is object. This contains the information that has changed, right? The new value. So that is a filter. And for that, we're going to declare another state variable, and it's going to be called search filter, or maybe call it server filter, because we are filtering servers, managing servers in different cities. And initial value is going to be empty. Now I want to assign the new value to the server filter here, and I'm going to say toString. And if this is null, then I'm just going to give it empty string. So we have server filter updated. So we can use implicit Razor expressions, just temporarily see the result. So we can say server filter here. And then let's run the application and see the result. Okay, come over here, and we have our search filters search bar. And you can see that it's actually grouped together with the search button. And if I type in something, let's say server1, and then I type out, now you can see that once the search bar lose focus, right, the input element lost focus, we got the unchanged event triggered and then reset the state variable. If I change it to 2 and I type out, I get server2, right? So that works. Now you see the whole process again, right? So user interact with the element on the view, and then event is triggered. When the event is triggered, state variable is updated, and then the view is updated. Right? This whole triangle is going on over and over and over again until the user closes the application. All right, now we have the filter. We can implement the search button. So we want to click on the search button and we want to filter the servers. So for that, we can come over here and we can add a onClick event here, right? onClick event handling here. And just to make the name consistent, I'm going to say handle search, and I'm going to go down and I'm going to say void handle search. Now this is going to happen first, and then this is going to happen afterwards. So therefore, I'm going to say this dot servers. Again, inside the event handling, we are updating the state variables. We're going to use the servers repository, and we're going to say search servers, and we're going to just provide the server filter here. And once we do that, you know, it doesn't really matter which cities we selected, because currently all of the servers belong to the currently selected city. Once you search for something here, for example, if you search server 16, then all of a sudden only server 16 is displayed here. It doesn't make sense to highlight Toronto anymore. So therefore, I want to clean up the state variable, which is the selected city. So select city, I want to set it to empty. So nothing is being selected. All right. So let's rerun the application and give it a try. Okay, at the beginning, it's Toronto, right? Toronto is selected. So let's go to Montreal. And now if I search server 1 and click on search, I get server 1, server 10, server 11, 12, 13, 14, 15, because I implemented this search functionality by using contains, I believe. So go over here, you can see that we're using contains to do that, and therefore we get all of these server 1, 10, 11, 12, everything that contains server 1, right? So if I say server 11, I click on search, I only get server 11. So therefore we have no selected city. Doesn't make sense to highlight any city anymore. But right now, if I click on Toronto, I get server 1, 2, 3, 4. Just need to remove this implicit Razor expression here. So go up and remove this. This is just for testing purpose. So let's rerun the application, make sure everything is clear, and working properly, right? So Toronto, Montreal, Ottawa, everything works okay. So servers, let's say server 2. Click on search, we get server 2, just server 2. And if we say just 2, right, then I get 2 and 12. If I put just 4, I should get 4 and 14. Okay, so everything's working, and at this moment, if I click on Calgary, I get 10 and 11. I click on Halifax, I get 12, 13, 14, and 15. All right, so everything seems to be working properly, and that's all I want to cover in this video. In this video, just to summarize, what we learned here is that we continuing on our journey of talking about the 3 different aspects of stateful application. And in this video, we're using a different event to change state. And that event is the onChange event for the input element. Right? When user input anything into the input box, this event is handled, and we're using a default parameter for this. Blazor is going to pass information to this parameter, and we are using the value property of the change event object here. That contains our server filter, and then further in the handle search event handler for the button, we're using that state variable to filter the servers. We're updating the servers again, right? This is another state variable, and this, once it's updated, the page component is re-rendered. And when the page component is re-rendered, the server here is re-rendered again. Right? That's the whole process. And that's everything I want to cover in this video. If you have any questions, please let me know. If not, I will see you in the next one. In this video, we're going to learn about two-way data binding. Previously, when we want to update the state variable, we have to handle an event. And inside the event, we're going to set the variable. Well, that's how it works. That's how all stateful application works. Right, we have to, from the view, trigger the events and update the state variable, and then the view gets updated. So this is how it works. However, there is something better, and that's called data binding. Data binding means that we're going to bind the state to the view. And the arrow actually shows a one-way arrow, means that the value is going to go from the state to the view. And now in this video, we are talking about two-way data binding. What does that mean? That means they're actually bound together. So any change on the view is going to come back to the state automatically. We don't have to use the event to do that. We can use the event to do something better. So that's called two-way data binding. And we are going to demonstrate that in this video. And we are going to use the search bar that we created in the previous video. You can see that here we're using the onChange event, and that is actually not necessary. As long as we can bind the server filter state variable to this input element, then we don't actually need to handle the onChange event. So let's delete that in this video. So we're going to delete this, and we are also going to delete this attribute here. Now we need to do the two-way data binding from the state variable, which is server filter, to this HTML element. And how do we do that? We can use something we actually learned a little bit before, which is the bind value, right? In the edit form, so let's go to here, we have this bind value thing, right? This time it's similar but different. So we're going to say at bind, and this time there is a bind value, and it is as simple as putting the variable right here. Right, the state variable. Now, there's a difference here. You see this? V is lowercase v, whereas in the form, it's capital V. So you have to remember this. You need to use capital V in edit form, and you need to use lowercase v in other places. So when we do this, the state variable and the element are actually bound together two-way, meaning that when the user is making changes to the input control, the value will automatically go to the server filter, right? Now, we don't need to handle the onChange event anymore. In fact, we have deleted. Now, if we give it a try, we will see that it still works. And we have our page running, and let's search server 1 and click on the search button. Now we have the result, right? What if I search server 11? Click on the search button. We get the result, which is beautiful, It's working, but that's not enough. We want to learn the mechanism behind it, right? Why this is working. Blazor, behind the scenes, is actually using the onChange event, but Blazor is doing that for us. So that's how it works. Right? Blazor, when it sees this bind value attribute here, it actually creates the onChange event handler behind the scenes, and it handles that. That's how it works. Another thing I want to mention is that sometimes you want to do something. You actually want to do something when the server filter is set, right? In other words, on the search event is not enough anymore. You actually want to intercept this automatic data binding. You want to see what is set, and then you want to do something. But with the two-way data binding, there's no event handling anymore. So how do you do that? How do you implement that? You can use a property here. So because here we're using just a private field, we can change this private field to a private property. So with a getter and setter like this. And then in the setter, we can do something. So because of that, we're going to create another variable here, and that one is called _ server filter, and we're going to set this to empty, and I'm going to delete this. Now inside the getter, obviously we can just return the server filter, but inside the setter, we're actually going to implement it. We're going to set the value to the server filter. And within the curly braces, you can do whatever you want. You may occasionally encounter this scenario where you have to intercept it, and you can use a setter to intercept that. You may encounter a little bit difficulty when you need to do asynchronous calls, but there are solutions, and you can search online for that. But here, this is where you do it. Another thing I want to mention is that this data binding, like I said, behind the scenes is using the onChange event. But sometimes you want to use a different event. So for example, as the user is typing, I want to see the result. That's one of a typical search functionality requirement. So in order to do that, I'm going to say assign -value and then :event. And I'm going to say I want to use the onInput event instead of the onChange event. And with this specified, this setter is going to be triggered for any input. So therefore, we can take advantage of this and do the search right here. Right? So because we're handling the search here, now we can actually handle the search here as well. So I can just copy and paste this over here. And instead of using this property itself, we're going to use the underlining field. And if we do this, let's run the application. We'll see what's happening. Application is running. If I say 1, immediately the server list is filtered. If I say 2, immediately I see server 12. If I say 3, nothing, right? Because it doesn't exist. And it's reacting for every single input. So I say serve, and then if I make a typo, nothing. Right? So it's actually reacting to every single input. I'm just typing and then the list is changing. So that's the beauty of two-way data binding. You don't need to do much. It's doing it for you. And you can just focus your energy on other things like handling this search button. In this video, we are going to learn about a little technical details about list rendering performance. So we want to use the key directive to improve the list rendering performance. And without using the key directive or key attribute here, there is actually a potential problem. So let's take a look. On our server's component, right, manage server screen, we have this for each loop where we render the server. So let's say we want to add a server into this with server interactivity. So let's say I'm adding a button right here, and this button is inside this paragraph. I just want to make some space. So we have a button, and I'm going to use button secondary bootstrap class just to make a difference from this one. Where this is temporary. We're not going to leave this over here. And for this button, the button's caption is going to be add server to, just to make a difference from here. Again, this is temporary. And the behavior of the button, obviously when we click on it, we want to add or insert a server into the server variable here. So we want to use the insert function, and we're going to insert at the first place. I'm going to create a new server. Server's name is server A, just some random name, and city is Toronto. And that's it. Right, so if we do this, and let's run the application and see what happens. Oh, bear in mind that we have already used the render mode interactive server on this particular page. That means everything in the page is going to work interactively, right? So server interactivity is enabled. That's why we can handle the on-click event like this and expect changes to happen. All right, so let's see the application. And we have our servers for Toronto listed over here. We have Toronto currently selected. And let's bring up our developer tool here. So let's scroll down and let's examine the list element here. So we have 4 list items here. Now, if I click on Add Server To button, I ask you to pay attention to this side. Okay? Do you see that every single list element is updated? Right? Every one of them is updated. I can try that again by clicking on the Add Server To button again, and this time again all of the list items are updated. Try that again, all of them are updated. So why is that? Why Blazor cannot identify the differences and only just patch the DOM so that it inserts a list item at the beginning, right, at the very top? Because that's where the addition to the list is, the server's list is. Obviously, Blazor doesn't want to go inside here and just look for differences, right? That would be too much for the algorithm to do. We only have this little information. It seems to be doable, but still not very easy to identify the differences, right? But imagine you have like thousands of items, maybe hundreds of items. It will be very hard for the algorithm, for the computer to do, for the server to do. So therefore, Blazor actually provides a key attribute here that we can use on the list. So if we scroll to the list right here, we can apply a key to help Blazor to provide a kind of identity, right? ID to this list item. Or if you want to use table, then this would be a TR element, right? And you can use this key attribute on the TR element. Any element you decide to use inside the loop, you can use the key attribute. And we just use it this way, add sign key, and then we provide a identity. Right? And in this case, it's best to use server ID. So I'm going to say server.server ID. And when I do this and rerun the application, let's take a look. Everything re-rendered. And we're going to examine the HTML again. Now let's click on Add Server To, and please watch this part on the right hand side. So I'm going to click. Now you can see only the first item is added to the list, right? The rest of the items are not touched. And if I click on that again, you see that it doesn't even add because it's illegal to Blazor to have 2 list items that has the same key, right? So it doesn't work that way. So therefore, using key attribute here really help us to improve the performance. So therefore, if you have a big list, right now we don't have a big list, but in your own project, very likely you're going to have a bigger list. And it is always recommended to use the key to identify the item. And of course, you have to make sure that ID that you use is unique. It cannot be the same. I have showed you, and I click on the button again, it doesn't work anymore because that kind of against the rule here. The key has to be the key, and it should be unique. All right, that's everything I want to cover in this video. If any questions, please let me know. If not, I will see you in the next one. In this video, we are going to talk about another technical detail regarding rendering items in the list, and this is called virtualization. This virtualization technique is used to improve the performance of rendering. Again, let's take a problem and solution approach. Let me present you the problem that we may potentially face. So let's jump into Visual Studio. And right now, our list only have a few items. So let me add some data to the list so that we are mimicking a scenario where you have thousands of items in the list, right? So let's scroll down, and then at the place where we select the city, I want to add a lot of items to one of the city. In this case, a lot of server objects to one of the city. And I think I'm going to do Halifax. Don't want to add it to Toronto, although practically it makes more sense because Toronto is a bigger city. It should have more servers, but I don't want to add it to there because otherwise you won't see the differences between, let's say, Halifax. So here, if the city is Halifax, then I'm going to do a for each loop. And it's going to go from 16 to 2000. Why I choose to do 16? Because in our models folder here, we have the servers repository. The maximum server ID is 15, right? So I'm going to go starting from 16. So from 16 to 2000. So we're adding almost 2000 items to the list. And we're adding server. So I'm going to create a server object. The ID is basically the index here. And the name is, just use string interpolation. So server starting from server 16. And the city has to be Halifax. All right. So I have the data prepared, which means when I click on the Halifax city button, the data will be added. And we're expecting to see a lot of data now. So let's run the application now. Go over here. Now, if I click on Calgary, you can see that the 2 servers are there. Montreal, 2 servers. Toronto, 4 servers. Now watch, I click on Halifax and you see it wait for a little bit before it displayed. Let me show that again to you. I have to rerun the application and then go back to servers, click on Halifax. You see that wait? So browser is working actually really hard in order to render all the items on the page. See, we have up to server 1999. So it's very hard working. And if I bring up our developer console here and I select this, you can see how many list items do we have. We have almost, well, I think more than 2000 of them. I'm just scrolling all the way down, right? And as I show all nodes, 1488 more. It's not actually showing all of them, but you can see there's already so many. So let me close this. So how do we solve this problem? Blazor actually has a built-in way to fix this problem, and that is called virtualization. And it's very easy to use. So a virtualization is basically replacing the for each loop. Right? Whenever you use for each loop, you can use virtualization. Well, that's not completely true. That's the first condition, right? You have a for each loop, and there's too many items. So therefore, that's one of the reasons why you need to use virtualization. Secondly, if items height is the same, right? The size is the same. What does that mean? You see this size, which is basically the height. For each item, they're the same. Pixel-wise, right? They're the same. They're about, I don't know, 80 pixels, 100 pixels. As long as they are the same, that's the other condition, right? And the third condition to use virtualization is that you do have too many items to show, right? If you only have like 100 items, 200 items, I think even 200 items, you can still use for each, right? But if you have too many, like more than 1,000, then use virtualization. So when those 3 conditions are satisfied, try to use virtualization. And the way to use it is very simple. Just remove this first and remove this curly brace. So remember, it replaces the loop, right? You just say virtualize. So it's like a component. And then you put what you want to loop inside the virtualized component. And then we don't have the server variable anymore, right? That was defined in the for each resource syntax. So we have to specify that. First of all, what are the items to loop through? Is this dot servers. Secondly, we need to define this server variable here. And to define that, we use this context attribute. We just say server. And you have seen some other stuff. And basically, this is the name. So we define the server variable here, and we use it inside the virtualized component here. And when we do that, let me run it, and you will know how it works. So start the application. Now let's go over here. First of all, let's see the result. So click on Halifax. Immediately, you see the list rendered, right? You don't have to wait. So if I scroll, you see everything is here, and it's pretty smooth, right? If we go back to Toronto and click back again, there's no wait time. So how does that work? If I bring up the developer console again and scroll down to here, and let's examine the HTML here, you can see that we only have so many items, right? I don't know, maybe 30, 25 items here. And it's not like all of the thousands of items are listed here. And you don't see that button here says click to load more. So we are only displaying about 30 items here. So watch if I scroll down. You see, items are being updated. See? And if I just drag all the way down, all of them are updated. So behind the scene, Blazor is doing really hard work, right? Especially that JavaScript file, blazor.web.js. It knows the height or the size of the item, and then it knows the viewport, like how tall this viewport is. And then it knows how many items need to be loaded or need to be rendered. And it only renders that many items. It doesn't render the whole thousands of items. It only renders that calculated number of items. And as you scroll down, it knows which item to render, which item to replace, and it only replaces those items that are not rendered, that are not on the screen viewport, right? That's why when I scroll slowly, only a part of, like the bottom of the part of the list items are updated. So let me try again, and you watch. See? Only these parts are updated. And if I do it even slower, if I use my keyboard here, the down arrow, you see only 4 items are updated here. So Blazor is calculating the viewport height and calculating how much you scroll down, and then it retrieves those items that stored in the memory and renders that on the browser. So with this virtualization technique, you are experiencing better performance. So remember those 3 conditions you're using for each loop, and you have too many items to render, and then the size of each item, which is basically the height, are the same. Those 3 items need to be satisfied, then you can use virtualization, right? It makes sense to use virtualization. And with virtualization, you don't have to use the add key attribute, as we mentioned in the previous video. You don't have to use that. It knows which items are which. There is a key applied already. Okay, that's everything I want to cover in this video, and I will see you in the next one. By the way, I'm going to remove this code. So we are not going to add thousands of items in there, but what I'm going to do is I'm going to keep the virtualization code here for you to reference in the future. Okay, that's everything I want to cover in this video. I will see you in the next one.